Indonesia is a beautiful archipelago country with a tropical climate and an enormous natural resource. Forests and their biodiversity are the most valuable natural resources and the natural capital of Indonesia. The forest area in Indonesia continues to shrink. The accelerated population growth has caused forest exploitation in fulfilling the demand for wood raw materials, both legally and illegally. While this demand keeps increasing, the wood supply continues to decline. Wood is a raw material that is greatly useful and valuable for humanity. It is used for construction materials, furniture, handicrafts, firewood, and a variety of household uses. Founded in 2002, the Research Center for Biomaterials, Indonesian Institute of Sciences, has been conducting research in natural materials, such as wood and natural fibers. The center also focuses on developing processes, technology, and design to produce value-added products. The Modification and Engineering of Biomaterials Research Group focuses on characterizing and modifying lesser-value wood materials into more valuable products. This research group works closely with another research group called Biocomposites Engineering and EcoStructure. They've been working on engineering wood-based materials and natural fibers, such as bamboo, into functional composite materials. This research group also works on building material design and providing a technology package of an eco-friendly home, known as EcoHouse. All parts of the EcoHouse use eco-friendly composite materials. It also utilizes an architectural concept that conserves electrical energy. One of the research interests of the Biomass Process Technology and Bioremediation Research Group involves the utilization of lignocellulosic materials, such as non-wood natural fiber, and incorporating their conversion process to create bioenergy or bioethanol. Lignocellulosic materials can also be used as a medium for making enzymes that are used in bioremediation processes. These waste-degrading enzymes can be used to remove color and toxic materials present in textile waste. This research group is also developing derivative products such as wood adhesives made from natural latex. These adhesives do not produce emissions of harmful substances. They are friendly to human health and the environment. The Urban Agricultural Pest Management Research Group has focused their research on maintaining the quality of the wood commodity and protecting cellulose-based products from the attack of pests such as insects and fungi. By utilizing natural materials such as plant extracts and microorganisms, this research group has been developing eco-friendly urban and agricultural bioinsecticides and studying their biocontrol approaches through laboratory bioassays as well as behavioral and ecological studies. The research outcome is part of this group's efforts to tackle the process of biodeterioration that is caused either by wood-attacking insects or wood rot fungi. Through a series of chemical, biological, mechanical, and physical processes, natural materials can be transformed into biopolymers, bioactive compounds, conventional composite materials, advanced and ingenious materials, as well as other products that are eco-friendly. In addition to providing high economic value products, natural-based materials can also be converted into renewable fuels as substitutes for fossil fuels. Appointed as the Center of Excellence for Lignocellulose, the Research Center for Biomaterial also has an ISO IEC 9001-2008 certification for quality management systems. It also serves as an appointed urban agricultural pest testing laboratory authorized by the Pesticide Commission of the Indonesia Ministry of Agriculture. Since 1996, the Research Center for Biomaterials has been a satellite office for foreign cooperation between LIPI with Kyoto University, Japan. The center is also active in research programs in Asia, such as JSPS and SATREPS. In addition, the Research Center for Biomaterials has been cooperating with various research institutions, universities, and industry from home and abroad. The Research Center for Biomaterials continues to develop advanced materials and bioproducts through a series of processes in order to support a clean and healthy environment. A Research Center for Biomaterials, Indonesian Institute of Sciences, appointed as a Center of Excellence, continuously advances innovation in addressing global challenges.
Okay, thank you for waiting. We also just watched the precious message from us, the committee for everyone, for our honorable keynote speakers, invited speakers, all the presenters, participants who give us your big support for us and show the excitement to join this event. Right now it is still raining in Bogor City, so it is a very touching moment for all of us this morning. But anyway, we are very excited to continue today's event, and we hope that all of you are truly enjoy our event today. So, Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, good morning local time in Indonesia, and welcome to the first international conference of Lignocellulose in conjunction with the 10th International Symposium for Sustainable Humanosphere 2021. I'm Fanny Clara Ardiati, and it is a pleasure to be your host today. So today is the second and also the last day of our event of conference and symposium, which is organized by JSPS Alumni Association of Indonesia in collaboration with Research Center for Biomaterials, National Research and Innovation Agency, BRIN, Republic of Indonesia. We would like to address our big appreciation for all the stakeholders who give their big supports to this event from JSPS Bangkok Office, Thailand, LAPAN, BRIN Indonesia, RISH-Kyoto University, Japan. We would like to also thank our valuable partners for their supports from many national universities in Indonesia, from IPB University, Padjajaran University, Islamic University of Indonesia, and Trisakti University. We also would like to thank our valuable partners from even far away in Sumatera and Kalimantan, from Jambi University, Lambung, Mangkurat University, Mulamarwan University, and University of Sumatera Utara. But before we begin, I would like to invite and appreciate everyone if you can turn on your camera so that we can see all of us here today, maybe to see your colleagues and everyone here. So, but please kindly remain turned off your audio during this morning session. Thank you. First of all, let me give a very warm welcome to our honorable guests who are already joined with us and will join with us today. To Professor Yoshio Otani as the Director of JSPS Bangkok Office. To Professor Masato Shiotani from RISH-Kyoto University, Japan. Also to Professor Kenji Umemura from RISH-Kyoto University, Japan. Also to Professor Dr. Ernasri Adiningsih as Acting Director of National Institute of Aeronautics and Space, National Research and Innovation Agency, BRIN. To Dr. Iman Hidayat as Acting Director of National Institute of Life Sciences, BRIN. To Dr. Akbar Hanif Dawam as the Head of Research Center for Biomaterials, BRIN. And to Dr. Didi Tarmadi as the Chairman of Icon-Lig and ISSH 2021. And not forget to also mention for our 13 honorable invited speakers who give us their supports by sharing their knowledge and giving us their lectures in this today's event. I would like to send my greetings for those our honorable invited speakers who are already joined with us today, to Dr. Wendy Harjupa from Center for Atmospheric Science and Technology, National Institute of Aeronautics and Space, BRIN. Also to Dr. Muhammad Haswan Husip from University Science Malaysia, and to Professor Dr. Wahyu Duyanto and Dr. Hoirul Himi from Research Center for Biomaterials, BRIN, who already joined with us today in this morning. And also welcome to all distinguished guests and participants. Thank you for joining us today. So in the annual event of ISSH, together with our first international conference of lignocellulose, now we bring up the topic of frontier innovation of lignocellulose and humanosphere sciences towards sustainable development goals and climate change mitigations. So for today's agenda, we will start by two presentations from our keynote speakers. And after that, we will proceed to the parallel sessions with all the invited speakers and presenters. To begin today's event, let me invite our first keynote speakers. So for Professor Masato Shiotani from Research Institute for Sustainable Humanosphere, Kyoto University, Japan, who will deliver the first presentation. So to Professor Masato Shiotani, please, time is yours.
Thank you very much. Just a moment, I should bring my presentation material. Can you see and hear my presentation?
Yes, Prof, it's very well.
Okay, so my name is Masato Shiotani, the director of the Research Institute for Sustainable Humanosphere, Kyoto University. Today, I'd like to talk a general story about the humanosphere sciences. And in the first part, I'd like to show some general idea and which we are now aiming at as a research institute. And in the latter part, I'd like to show one good example of the humanosphere sciences, I believe, which is kind of characterized as a diagnosis and remediation of the Earth. So what is the humanosphere sciences? So as I said, that it is characterized as the diagnosis and remediation of the Earth. So we define the humanosphere as the sphere that supports human activities, including human living environment and forest sphere, the atmosphere, and the space environment. So here, just a moment. This is a cover page of a brochure of our research institute, and it's said the RISH and the space environment and atmosphere and forest sphere and the living environment. This is also described in the left panel. So we are trying to investigate to present the future programs of the humanosphere and explore innovative technology that will contribute to establishing a sustainable society in harmony with the natural environment. Actually, our English name of our institute is Research Institute for Sustainable Humanosphere. So I think the sustainability is one very important keyword here in the RISH. So why do we need such a sciences, kind of interdisciplinary sciences? So we are now facing the several hazardous events threatening the existence of humankind. So now we're facing the global warming, and it is becoming tangible, and consequently, with the disasters are intensified. And also, long distance communication is providing us kind of infectious diseases in the world that's becoming highly prevalent. So these problems are, just a moment. Okay. So this picture in the write down should be movie, but it's not moving. I'm sorry about that. So these programs are very complex in nature, and therefore only deepening academic knowledge in a scientific area cannot answer this complicated problem. So we need to investigate our expert knowledge in various areas with an interdisciplinary view. Okay, here. So this is one example of the last very heavy rainfall in the southern island of Japan, Kyushu Island. And so we had very serious problems after this, during this event. So humanosphere science is a kind of a subset or related, very closely related to the sustainability science. And the Sustainability Development Goals, SDGs, are a collection of 17 interrelated goals designed to be a blueprint to achieve a better and more sustainable future for us. And the SDGs was set, just a moment, sorry about this one. So SDGs was set in 2015 by the United Nations General Assembly and intended to be achieved by the year 2030. They are included in the United Nations resolution called the 2030 Agenda for what is colloquially known as Agenda 2030. And so our research institute, RISH, can not all, but the wide range of this, the SDG goals. And so we should keep our mind to the output toward the public and also the political area as a scientific achievement. So in our institute, we set 5 missions. By integrating the research result, we pursue solutions to present the future progress concerning the humanosphere. So mission 1 is environment diagnosis and regulation of circulatory function, and mission 2, advanced development of science and technology toward a solar energy society. Mission 3, sustainable space environment for humankind, and mission 4, development and utilization of based sustainable materials in harmony with the human living environment. And mission 5 is closely related to the quality of the future humanosphere. So I'm not going in detail about these mission items, but we set those missions to achieve our goal. Our research institute, RISH, is also characterized as the Joint Usage Research Center. So we need to tackle these interdisciplinary problems in a new academic area. We have to have a good research materials or research instrument. So here we have several very unique instrument or facilities to investigate the humanosphere sciences. And also we have a database that is for open use for the public. And also we are doing a project type collaborative research for promotion of collaborative projects. And as a part of our RISH activities, we, in 2016, we initiated a new program named Humanosphere Azure Research Node, ARN, so which is trying to strengthen the hub function of international collaboration, collaborative research, and fostering innovation in humanosphere science with the ultimate goal of delivering solution on a global scale. So this is focused in the Southeast Asian countries, and also so people living in South Asian countries, scientists in South Asian countries, and also we have an equatorial atmosphere later in the Indonesia. So we are utilizing the facilities and the human relation for the further humanosphere sciences. We have a promotion video, or we made a promotion video last year, but I don't have enough time to show during my presentation. So if you are interested in our activities in RISH, please visit here. This is our website, and you can easily find this video, and you can see or enjoy our promotion video. So in the following, I would like to show one historical example related to the humanosphere sciences, I believe. So this is an event, or this is a case about the ozone depletion. Ozone is mostly located in the upper atmosphere, and that is that produced the Antarctic ozone hole. So atmospheric ozone had been exceptionally depleted in the stratosphere over the Antarctic during spring of Southern Hemisphere. This was first documented in 1985, almost 35 years ago. And scientists performed extensive measurement from ground-based sensors and satellite and aircraft, so very complementary and complicated way. So they're trying to describe this event very minutely, or in that sense that globally. So based on these observations, the theoreticians proposed mechanisms for the depletion. And they finally concluded it is due to the release of the man-made chlorofluorocarbons and other halocarbons. And so the scientists resolved the kind of this very important question. And most importantly,
Kapan ya? Besok? Direbus dulu nggak sih biasanya, Pak? Kalau martiger gitu?
And most importantly, this result is contributing to establish international kind of the structure, Montreal Protocol, that is an international treaty designed to protect the ozone layer by phasing out the production of ozone depleting substances. And the final line that the import that is taken from the recent scientific ozone assessment report, ozone depletion scientific ozone assessment report. And in the first important sentence, they said that the actions taken under the Montreal Protocol have led to decreases in the atmospheric abundance of controlled ozone depleting substances, and the start of the recovery of ozone, stratospheric ozone. So this is a very important message. And you may not know detail about the ozone hole, and you are now living very healthy and not problem world. But this is kind of realized under this Montreal Protocol, I can say. So I will just introduce some history of the ozone hole discovery and some investigation, and also some achievement of such an investigation. So this is an observation that Hare Bay is located in the Antarctic supported by British Antarctic Survey. And this is the time total ozone section. So this shows the total ozone time series during the October from the end of 1950s and the middle of 1980s. And up to middle of 1970s, the ozone amount is rather flat or not so changing. But after that, the ozone is quickly decreasing in the Antarctic area. And here, the author, Farman, showed the fluorocarbon amount. So the axis is shown that the increasing in the downway, and so the fluorocarbon is increasing, and at the same time the ozone decreasing. So they pointed out the relation between the decrease of ozone and the fluorocarbon. And this is also confirmed in the satellite observations. So this is the monthly mean total ozone in October observed by total ozone mapping spectrometers. And they use the South Polar projections with the pole indicated by a cross and the 30 degrees south latitude by dashed circles. And so we see some ozone small area here over the South Pole or the Antarctic area. And here the number is 270 and 240, 210. And finally, in 1985, 180. So the ozone is rapidly decreasing during this season. So this is also confirmed with the kind of in situ observations using the ozone sonde. So the sun ozone instrument is here, and this is launched with use of this big balloon. And by the way, this is an observation at the South Pole, supported by the United States of America. And usually we see the ozone amount is like this, so we can see some ozone layer here. But in 1992, October 11th, or in 1993, October 12th, we see almost nothing of ozone here in the height range of 15 to 20 kilometers. So this is the actually affected by the total ozone. I didn't say about the unit of total ozone, but the total ozone is a kind of accumulation or integrated amount of ozone. So the ozone is highly depleted in the ozone layer here, in this case in around 50 to 20 kilometers. So such a decreasing trend is continuing in the 1990s. And so such an ozone hole is deepening and deepening. And here there are actually 4 South Antarctic stations, South Pole, Hare Bay, and the Japanese station Showa. And so it's very critical and hazardous to human. And the mechanism of the ozone hole is very closely related to the polar stratospheric clouds. So I'm not going in detail about the mechanism, but on the polar stratospheric clouds, there happened the heterogeneous reaction in the surface of cloud droplet, and it is very important to release the chlorine compound originally from the chlorofluorocarbons. So here is a schematic diagram of the mechanism of ozone hole. And I'm not going in detail about this mechanism, but here you can see the chlorine compound. There are many chlorine-related compound. And this chlorine is originally from the chlorofluorocarbons. So chlorofluorocarbon itself is very stable atmospheric constituent, but if so, the sheer chlorofluorocarbons going up to the very high altitude, it is photochemically dissociated, and so they release the chlorine, and such a chlorine is affected on the ozone depletion in the springtime of the Antarctic regions. So after the discovery of the ozone hole, the several supporting the observations have been done. So this is one example done by the airplane, and this is very simple for the latitude and ozone, and also the CLO. CLO is a product that indicating the ozone. So the probably flight going from low latitude to the high latitude. So we see the clear ozone depletion around 64 or 5 degrees south. And at the same time, CLO is increasing. That indicate the chlorine is a very critical destroyer of the ozone here in the Antarctic stratosphere. So this is also the result from the satellite, and we are focusing on the first upper right picture. This is an ozone observation done by the satellite. So instrument name is MLS, and we see, so actually this is the almost South Pole. The black area is not the data. This indicates the no data area, so this is not clear data presented here. And we see the rather small ozone here, and at the same time we see the enhancement of CLO here, and we can say that the chlorine that is originally from the chlorofluorocarbon is destroying the ozone over the Antarctic in the lower stratosphere. So in such a critical condition, the international community established the Montreal Protocol, which is an international treaty designed to protect the ozone layer. So this is a diagram showing the time and equivalent stratospheric chlorine. So how much the chlorine is released in relation to the chlorofluorocarbons. And if we didn't, if we don't have such a protocol, the chlorofluorocarbon amount is released. So the release amount is very rapidly. And so as suggested in Montreal Protocol, this is slightly decreased. So this is a kind of, so we should do this, but it's not so strong. So after that, there are several corrections of this future projection, and now we are in the sense of the zero emission in 2011 about the fluorocarbons. And actually the fluorocarbons, there are many variants. So, and we see that the most fluorocarbons, most of those species are kind of peak and also show some decrease here. And this is a picture taken from the recent scientific ozone assessment of ozone depletion. The first figure of the general summary. And here, this diagram shows the chlorofluorocarbon release, how the release of the chlorofluorocarbon is going in the time series. And after the Montreal Protocol, the such a release is rapidly decreasing here like this. So it's a good indicator at the first look. But as I said, that the chlorofluorocarbon is a long-lived species in the atmosphere. It's not so easily destroyed. But as I said, that in the stratosphere, it is slowly destroying. So the equivalent effective chlorine in the stratosphere is not so sharply decreasing, slowly decreasing. It takes about 100 years and so on. And corresponding to this, the decrease of the effective chlorine, the ozone is now slowly recovering. And this is a message, as I said, that here. So now we can see the start of the recovery of the stratospheric ozone. So now I'd like to show some of the computer simulations with Montreal Protocol and without Montreal Protocol. This means that if we take this route, so in that case, the scientist couldn't find answer about the atmospheric phenomenon. So scientists cannot understand why this ozone depletion is happening. So this is a no protocol case, and now we're taking this route, zero emission case. And so again, we cannot see the movie here. I'm sorry, this is a movie, but cannot show you that you can see this web page, the original version of the movie. And in the next figure, this is a summary of the time series of total ozone with and without Montreal Protocol. So with Montreal Protocol, so this is a world we are now living. So owing to the Montreal Protocol, we are now living in the very healthy Earth. And ozone amount, this is an ozone amount in early 2000 and up to 2070. So the ozone is slowly recovering, but not drastically decreasing. So the Montreal Protocol works very well. But without Montreal Protocol, so in that case, as I said, that scientists didn't understand, cannot understand the mechanism of the ozone depletion. After around here, 2020, the situation is not so big compared with Montreal Protocol. But after that, the ozone layer is catalytically destroyed. And around 2030 and also 2040, there is no ozone layer in the atmosphere. So we are very happy. So now we are living in this with Montreal Protocol, but not without Montreal Protocol. So here is a summary of my talk. So the role of the Humanosphere scientist is to aim to investigate the present and future problems in the Humanosphere. So this is a kind of data diagnosis, and theoretically explore treatment of these problems. This is a kind of remediation that will contribute to establishing a sustainable Humanosphere. So very healthy and good condition of the Earth now. So more importantly, such results should be delivered to people in public and political sectors and implemented in proper way, like a Montreal Protocol. An example about the ozone depletion is one of the most successful demonstrations in human history. And so in collaboration with scientists and politics and public people, and it should make the best use of the current problems we are facing, like global warming and due to the greenhouse gases increasing. So that's all my talk. Thank you very much.
Thank you very much for Professor Masato Shiotani for the interesting topic related to our theme and the perspective of the RISH-Kyoto University, Japan. Thank you very much. Next, we will hear the second presentation from our second keynote speaker, from Professor Dr. Ernest Riyadiningsih as the Acting Director of National Institute of Aeronautics and Space, National Research and Innovation Agency, BRIN. So I would like to invite Professor Erna to deliver her presentations. So Professor Erna, please, time is yours.
Yes, thank you, MC. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. I hope you all keep healthy. Thank you so much. And first of all, I would like to thank that the organizer of this important symposiums invite me to speak on behalf of LAPAN. I would share my presentation material from my screen. Sorry. Could you see it?
Yeah, yes,
okay.
It's very clear.
Thank you. So I would like to raise on important topics, although LAPAN as the Aeronautics and Space organizations not really dealing directly with the what you call it most of the participants here is doing in their research. I would like to raise about the importance of space-based science and technology, and to support, particularly to support sustainable development goals and climate mitigations. I would like to introduce, my name is Ernest Riyadiningsih, and at the moment I'm appointed as the acting head of a new name of LAPAN. Still we have the name of LAPAN, but the acronym is quite a bit different. You know, not a National Aeronautics and Space Institute, but we are now become Aeronautics and Space Research Organizations, and we still have the LAPAN as the name of a space agency in Indonesia, and we are now under the National Research and Innovation Agency, or BRIN. In this particular symposium, I would like to share some of the important issues on how not only our organization structure already transformed into a new form of organizations, and but also facilities on the scope of our activities. And data. And next is the activities to support the SDGs number 14. This is life and below water. And one of the activity is on a coastal aquaculture site selection monitoring in the Central Java and North Sumatra. And this research is to provide the result of this research is how we can provide the marine resources management and fisheries in the management area. One of the example is we have produced the mangrove distribution area, including its changes time to time. For example, this is the area in Segara Anakan and also in Nias Island, North Sumatra. And this is another activities dealing with the SDGs number 14, life below water. We are using the daily resolution satellite data, but with a lower spatial resolution, but we can provide the information based on the parameter of the sea surface temperature, as well as the chlorophyll content, to provide the potential fishing ground area in Indonesia. And this is quite well developed, and the users also can use this information in a mobile platform, so that the fishermen can easily utilize the information in their daily activities in fisheries or in a fishing to find a fishing ground of any particular area in Indonesia. Next is the activities related to SDGs number 15. This is life on land, and the most significant activities that already adopted by the authority in the Ministry of Forestry and Environment is the forest degradation and deforestation monitoring by using the data to provide information on the degradation of any forest area. And this is an example in the Sumatra and Riau area. This we can see the forest cover in particular area from 2016 to 2017. And what is the goal of these activities is we can achieve to extend the degraded conservation, and also we can monitor the restoration action plan conducted by the Ministry of Forestry and Environment. Next, I think by sharing about the some of our activities in our in our institution, I think what we are just want to summarize. Sorry, I think is that the use of satellite-based observations is quite useful and beneficial for addressing sustainable development goals, as well as the climate change mitigation. Of course, in doing that, we have a very intensive collaboration with various institutions at the national level, local level, as well as at international collaborations. And we also invite all researchers from all institutions in universities and international organizations to be part of our research activities, our program, to improve the use, to improve and to promote the use of space-based technology and application in addressing sustainable development goals and climate change mitigation. I think with that, I would like to end my presentations. Thank you very much for your kind attention.
Thank you very much for Professor Erna for the sharing in perspective from LAPAN, Brin. But before we close our morning sessions, I would like to invite everyone to join the photo sessions. So please, I would like to appreciate if you can turn on your camera to take the pictures together. So for today, we will help by Dr. Maya, if you are ready.
Yes, I'm ready.
Okay.
maybe I can start. Can you hear me? Maybe for Miss Nisa.
Lesti, could you please turn on your microphone because we cannot hear your voice clearly. Thank you.
Okay. Okay, now, can you hear me?
Yes, yes.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Resti Marlina, your moderator for today. And with a great pleasure, I welcome you to parallel session 5 that focuses on biomass conversion 2 in the second day of the first international conference of Lignocellulose in conjunction with the 10th International Symposium of Sustainable Humanosphere 2021. And before we start the session, I would like to remind you that we would love to deliver an interactive session between you and the speakers. Therefore, for the presenters, we invite you to turn your camera on once we start introducing you, playing your video presentation, and beginning the Q&A session. And for the participants, we also welcome you to do so. However, if you are shy to turn your camera on, you may use the raise hand button on your screen to deliver your question, or you can write your question in the chat section. And for the best audio quality, we recommend you to use any listening devices. And since this is an online forum, you surely may enjoy the session together with your colleagues at work or family at home. And this conference also be accessed through our official YouTube channel, so you can also may stream it live from your phone, PC, tablet, or laptop. And now let's start our session by inviting our distinguished speaker, Professor Muhammad Haswan Hussein. Professor Muhammad Haswan Hussein is an associate professor in the School of Chemical Science. Hello, Prof. How are you, Prof. Haswan Hussein?
Assalamualaikum warahmatullahi wabarakatuh. Yes, alhamdulillah.
Waalaikumsalam warahmatullahi wabarakatuh. Maybe I will read your short bio first, right?
Sure, go ahead.
Professor Muhammad Haswan Hussein is an associate professor in the School of Chemical Science, USM, and currently he is a deputy director of Research Management and Creativity Office in USM. He received his bachelor degree in chemistry and master degree from University Science Malaysia. He was awarded PhD degree in 2014 at Université de Lorraine, France, and had become visiting lecturer at Université de Lorraine as well. Currently, he is a research fellow at University Malaysia Perlis, and his research area involves lignocellulosic materials, lignin, cellulose, and adhesives. He has many publications in reputable journals and also active to publish his work in many conferences, either national or international. And Professor Hussein also active in giving consultancy related to advanced material to many reputable companies such as Robert Bosch, Precision Electronic, and many more. And yeah, I think Professor Hussein already joined with us today. And how are you, Prof? I hope you're doing well. Welcome to our event, and it's very pleasant for us to have you join live in this session. We thank you very much for your great contribution to our event, Prof.
You're welcome. You're welcome. Thank you again for the invitation.
Okay. And if you don't mind, please let's start this session.
Okay, sure.
Okay. Now let's hear the presentation of our invited speaker, Professor Muhammad Haswan Hussein, with the title Anti-Corrosion Properties of Epoxy Zinc Oil Palm Frond Cellulose Nanocrystal Composite for Mild Steel Corrosion Protective. And before we listen the video presentation, I kindly remind for all presenters and participants to make sure that you have mute your microphone during the presentation time. Thank you. And IT team, please play the video of our invited speaker to Professor Muhammad Haswan Hussein. Enjoy the video.
Hello and good day to everyone. I hope you guys are doing fine during this pandemic. My name is Muhammad Haswan Hussein. I'm the Associate Professor in the School of Chemical Sciences, University Science Malaysia. I would like to thank the organizing committee for inviting me to this conference as an invited speaker. And today I'm going to talk about a research from our group entitled Anti-Corrosion Properties of Epoxy Zinc on Palm Cellulose Nanocrystal Composites for Milestone Corrosion Protection. And basically, before we move further, let me just briefly explain to you about the problems that we face currently regarding on corrosion. So corrosion by definition is actually a destruction of metallic substance by chemical or electrochemical reaction with its surroundings. And when we talk about the surroundings, it is actually by means of the composition of oxygen and water that contains in the environment that triggers the corrosion process. And we cannot run away with the redox process, where during the oxidation process, metal will be oxidized, and with the presence of water and also oxygen, during the reduction, it will produce hydroxide ions. So these ions, the metallic ions, combine with the hydroxide ions to form a so-called rust. And it is one of the most problematic issues in every countries. In fact, every country's GDP will spend like around almost 5% of their GDP for maintenance and also for repair due to corrosion. And some incidents that occurs recently in Italy, 2018, where the Moradi breach incident happens. This is actually a very catastrophic incident where a bridge was collapsed and the problem actually caused by the corrosion of the structure. So of course, this would be one of the problematic issues that we have currently. And when we talk about the use of steel in various industries, especially in mechanicals, in construction and whatnot, it has been grow annually, and the demand for mild steel, of course, is very high. This is actually due to the highly mechanical strength, their price, and also their durability. But due to the corrosion process, some industries have implemented several techniques in order to control or to reduce the corrosion of mild steel. This is actually by means of introducing corrosion inhibitors, like the use of chromate or phosphate salts. And apart from that, the use of coating could be useful as well in order to protect the mild steel or the steel from corrosion. But all this actually have its own advantages and disadvantages. Of course, the process is very cheap and highly efficient, but in terms of the toxicity of the chemical used during the treatment is highly toxic and could be harm to the environment. So we need a further investigation or a further study in order to make the types of corrosion protection methods such as coatings or inhibition will be less toxic. And the use of epoxy zinc coating for metal protection have been vastly used. The use of coating is that basically to create a barrier between the metals and the surrounding. So when there's a barrier, then there's no direct interaction between the metals and also with the presence of oxygen and water. Epoxy is becoming a very highly demand because in this case, epoxy will be used as a polymer, as a barrier to prevent the corrosion of ions to reach the metal surface. And at the same time, the addition of zinc into epoxy coating will be useful because it will actually give a secondary protection due to galvanic protection. And this actually will mitigate the corrosion process. And of course, when we talk about the use of epoxy zinc coating, the mechanism will be different as well, because when you have zinc in the coatings, zinc will be oxidized rather than the metal that is been coated. So this will eventually give some sort of like a sacrificial effects to the metals, and making the steel to be protected will be not harmed. And the use of nanocrystal cellulose as a filler have been currently emerging. This is actually due to the use of various kinds of nanofiller. We know that the properties of filler to increase the strength and also the mechanical properties of any composites or anything. So the idea is basically to include cellulose nanocrystal as a filler in the coating so that it can actually increase not only in terms of the corrosion protection properties, but also in terms of the mechanical properties. So the nanocrystal cellulose, by means of their own properties, it is actually environmental friendly, low cost. It can be obtained from various types of biomass. It has a high surface area and also good mechanical strength. And it has been used for various types of applications such as packaging, composites and plastic, biomedicals, and also aerogel. And when we talk about the source of cellulose nanocrystal, we cannot run away from biomass, because we know that this is actually one of the important sources to produce cellulose, or also cellulose nanocrystal. So we know that the oil palm industry in Malaysia and also Indonesia is quite large, and we do produce a lot of waste at the same time. So the amount of waste produced without further utilization would be very problematic. So the idea is basically to utilize this biomass so that it can be converted into a useful chemicals. And from all this biomass from oil palm, we know that oil palm fronds contribute the largest amount of biomass, which eventually, because of the pruning process that been done in plantation. And the study of epoxy nanocomposite coatings have been done previously by various authors, not only by the use of nanoclay or inorganic fillers, but also with the use of organic fillers, for example, conductive polymer and others. In fact, some of the studies also have used cellulose nanocrystal or microcrystal cellulose as a filler, and they have actually revealed that with the addition of this cellulosic base filler, it can actually improve in terms of the anti-corrosion properties and also the mechanical properties. Therefore, our problem statement is because of one, the current cost of corrosion protection, which quite huge annually. The second thing is because of the toxic containing chemicals in the coating formulation that makes a problem due to environment, and also due to the highly porosity of epoxy zinc coating, because when you have epoxy zinc coating together, when the zinc become oxidized, it become porous, and this can actually lead to the absorption of water and also oxygen that can penetrate into this pit and later forms filiform corrosion and whatnot. So we need a filler in order to counter that problem. And of course, the last problem would be the use of or the amount of biomass waste produced from oil palm activities without proper utilization. So this could be a few problems that we are trying to overtake in the end of these studies. So therefore, we are trying to produce or to prepare cellulose nanocrystal from oil palm fronds by various techniques, and after that we are going to characterize it using complementary analysis. And next we are going to fabricate, we are going to dope this cellulose nanocrystal into epoxy zinc formulation, and we are going to go next on to the anti-corrosive performance of this epoxy zinc coating with and without the modification of CNC. And finally, we are going to compare the performance between the produced epoxy zinc CNC coatings with the commercial paints or zinc chromate paints. So for the experimental, it's quite easy to isolate cellulose nanocrystal. What we did was the oil palm frond biomass will first be grounded, and then after that it will be treated. We are doing autohydrolysis pretreatments in order to remove most of the hemicellulose, and then after that we perform bleaching and mercerization in order to remove most of the lignin and also trace of hemicellulose that's still contained. And after we obtain the alpha cellulose, we are going to hydrolyze it using acid hydrolysis method to finally obtain cellulose nanocrystal powder. So this cellulose nanocrystal powder will be next characterized using FTIR NMR, solid state NMR, XRD, thermal analysis, BET, surface area, SMEDX, and also TM. And in fact, after we did all this characterization, we are going to dope the CNC powder into our epoxy zinc formulation with various amounts of zinc and various amounts of CNC filler. And once we have coated on the master plate, what happened next was we analyze it in terms of the electrochemical behavior using electrochemical impedance, potential and polarization, opposite potential. And we did also the thermodynamic studies in order to see whether the coating can last at different temperature. And finally, we also did the surface analysis to see the durability of the coatings that been produced. So for the proximate analysis of the open fronts that we did, most of this is actually the content of our open fronts. It is more or less quite similar with the previous work done by Latif et al.
Recording in progress.
Excuse me, dear IT, could you please assign me for the break room? Thank you.
Recording stopped. Recording in progress.
That the types of cellulose that we obtain, or the CNC that we obtain, are highly crystalline as compared to the alpha cellulose. And talking about crystallinity, we also did the XRD analysis, and we also calculate the crystallinity index. And from here, what we obtain is that the CNC produce slightly higher crystalline index as compared to the alpha cellulose from the OPF. And from here also we can indicate that the types of cellulose polymorph that we obtain over here is basically cellulose type 1. And in terms of the thermal stability, it has been revealed that the CNC exhibited slightly higher thermal stability with a slightly higher DTG max, around 388. And in fact, from the DSC analysis, the melting temperature obtained for the OPF CMC is also slightly higher, not even much difference, but just slightly higher to that of the alpha cellulose. So this actually can give us an idea as well that how stable the CNC that we have obtained so far. So in terms of the physical stability, it has been justified. And of course, when we talk about the porosity, we just want to see how much it has been improved after we did the acid hydrolysis, and we are comparing the alpha cellulose OPF and also the CNC OPF. And from the BET analysis, we have seen that the BET surface area have been increased from 7.14 into 26.10 for, after the acid hydrolysis. So this actually tells us the acid hydrolysis treatment that we did give more porous properties to the cellulose. And at the same time, we also did the TEM analysis, and from the TEM analysis, it can be revealed that the average length and also the diameter were basically around 95 nanometers and also 6.8 nanometers respectively. So with a compact size of a OPF CNC, it made easily to be incorporated in the epoxy matrix. And we have proceeded the analysis into the corrosion analysis, as what I have told you guys earlier, that after we obtained the CNC, we drop it into our epoxy zinc formulation, and this is what we did first after we coat it on the mild-steel plate. So the electrochemical studies by means of electrochemical impedance and potential polarization have revealed that as we put or as we increase the amount of CNC, what happened is that the resistance charge transfer is getting higher. So the increase of resistance charge transfer actually tells us that the metal will be more resistive, and I think the corrosion can be lowered. In fact, for the potential dynamic polarization analysis, what happened over here is that when we introduce the CNC into the formulation, the current density of metal become lower. So lower current density actually give lower corrosion rate, and lower corrosion rate means that it gives a very good corrosion protection. So from here we can reveal that with the addition of 0.5% of CNC give the highest or the better protection as compared to different amounts of CNC. And for the thermodynamic studies, we also have seen that when we include 0.5% weight of CNC, the activation energy will be increased. I mean, if we compare the epoxy zinc without any filler. So this can tell us that the increase of activation energy is basically due to the very strong chemical interaction between the metal substrate with the composite or the coatings. And talking about the corrosion protection, we cannot also run away with the mechanism. So what happened without any filler was that, as I said earlier, the zinc after oxidation, it will form zinc oxide, and this zinc oxide become porous. And if there's no filler, what happened is that it will create a pore, and the possibility of water, chloride ions, different types of species to penetrate is higher. But when we include or when we dope with the cellulose nanocrystal filler, what happened is that the structure will be more rigid, and this actually prevent the formation of a porous material in the end. And from the surface analysis, what we have done using the anti-iron analysis is just to justify the interaction between the CNC and also the epoxy. And of course, we have detected a various trace peaks of I think formation between CNC and also epoxy. But this, of course, very preliminary, and what we can tell is that the cross-linking between the epoxy CNC will generate the hydroxyl or ether group in the end. And moving on to the next characterization of the surface, we also did with water contact angle. And from the water contact angle analysis, it has been revealed that as we put the CNC filler, the hydrophobicity or the water contact angle become higher. So we attain around 105 degree of water contact angle after we have doped with 0.5% of CNC. And in comparison with epoxy zinc alone without CNC, it's around 86, and without any coating around 59. So we can see clearly that with the addition of CNC, it can actually improve in terms of the hydrophobicity. So a better hydrophobicity is very good for coating because it can actually repel the attachment of water on the surface. And when we compare with the commercial brand also, the commercial epoxy zinc attained around 91 degree. This is slightly lower as compared with the one that we have produced. We also looked through the surface roughness using atomic force microscopy, and what happened is that after we add the 0.5 weight% of CNC, it actually produces a smoother surface, and without any coating, of course, the surface is rougher. And the well dispersed of the epoxy matrix is actually showing that there's no major agglomeration happens during the coating. We also did adhesion and also the hardness test. So for the adhesion test, what we did was, after the plate was coated, we put the X mark, and then we did a pull-off test. So the pull-off test actually to detect the peeling on the scratch. So if you can see from this picture, it is not much different, but you can see clearly that with 0.5% of CNC, the peeling or the peel, I think the effect was not really tremendous as compared to without any filler like CNC, and with the higher amount of CNC as well. And in terms of the hardness, it has been revealed that when we put CNC filler, it increased the hardness value. So this actually in accordance with our hypothesis earlier that when we add filler, it actually improves in terms of the durability or the rigidness of the coatings. So as a conclusion, what we have found out from this study was the CNC was successfully extracted. And we have also characterized it and confirmed that the CNC from OPF had good properties. And after that, we also have proved that the CNC, which have been doped together into the epoxy coating, shows a very good anti-corrosion and also surface properties. So this actually a very good outcome. And finally, we also have seen that the results is comparable to that of the commercial zinc chromate paints. So this is part of the reference that we did, we used for this study. I would like to acknowledge my student, Ms. Nurfatin Simi, for her hard work. And I would like to thank Universitas Malaysia also for providing me the Research University Incentive Grant. And for more info, you can check out our latest publication regarding on this work published in the International Journal of Biochemical Molecules and also Cellulose. So with that, thank you very much for your kind attention, and I hope you guys to stay safe and stay wherever you are. Thank you very much.
Yeah, okay. Thank you, Professor Hassan Hussein, for your amazing presentation. It's very interesting topic about the anti-corrosion properties of epoxy zinc oil palm front cellulose nanocrystal composite for mild steel corrosion protection. And now we begin the Q&A session. And because Professor Hassan Hussein already with us, so we will have the live Q&A session with him. And for the participant here, please welcome to give any question for Professor Hassan Hussein related to his topic. And I believe that now we have several participants who like to address question. So invite you to use the raise hand icon on your screen in the reaction button. And we are so excited if you would love to turn your camera on. Okay, I have a question for Mr. Dedi Triono. Please, you can ask the Professor Hussein directly.
Yes, thank you very much for the opportunity. Professor Haswan, this is very interesting study. Yeah. But I'm afraid I missed some part of the beginning of your presentation of the film, because this is the film. I just want to ask you about the you in this study you study about you use the crystalline nano cellulose crystalline nanocellulose for as the material to utilize and as a filler for the corrosion protection. I would like to ask you, what is the importance of the crystallinity of the cellulose for to be used in this study? Because I'm afraid when I see the protocol to make this filler, sometimes there is some process, and I'm afraid there is very low very low yield of the crystalline nanocrystal. And maybe it's related with my second question: how to determine the parameter of the hydrolysis, and finally you can find the crystalline nanocellulose, crystalline nanocellulose. Yes, maybe that's it. I'm so interested with this study. Thank you very much.
Okay, thank you very much, Pak Dede, for this question. Of course, as mentioned earlier, so all the while we have utilized cellulose nanocrystal for different kinds of application like composites and whatnot. So recently there's like an interest of seeing the impact of using CNC in coatings. And the reason why is because we just want to see the role of CNC as a natural filler rather than the use of inorganic filler. Okay, so your first question basically asking about the importance of the crystallinity of this CNC to take part, to contribute in terms of the anti-corrosion properties. So as I'm explaining in a few slides, the normal coating itself, when I'm quoting about the types of coatings that we use over here is epoxy zinc. So the epoxy zinc coating itself, when it corroded, because eventually the zinc will be corroded, will be oxidized and become porous. So we need something to actually to fill in the gaps, and this is actually the reason why we use a filler. And talking again, the use of CNC because of, like the CNC itself, it has a very good properties in terms of the mechanicals, and also it has a very high porosity, the high surface area. So these actually will be the drawbacks of the problems that faced by the normal coatings without any filler. So the other, the other question, the second question regarding on the parameters of these hydrolysis. So of course, whenever we do hydrolysis in order to get cellulose nanocrystal, we do look in the several parameters like the times, the concentration of acids, and others. So in this case, we are using the optimized condition we have like studied previously using acid hydrolysis, and then with optimal conditions of like 50% of sulfuric acids with at the room temperature and 30 minutes of stirring, it actually provides us a very high crystallinity. So the crystallinity index is actually measured using XRD and also solid state NMR method. So that is why what we are trying to look here is that when we utilize a higher crystalline CNC as a filler, it actually improves in terms of the mechanical properties, the hardness test, and as well as it gives a better resistance in terms of the anti-corrosion properties. So I hope it answers your question, Pak Dede.
Yeah. Yes, that's very interesting for me. But maybe one comment about this one. Have you ever? It's not comment, sorry. It's a question. Do you have some comparison between the non-crystalline? Only the use of normal cellulose compared to the crystalline cellulose for the corrosion protection.
Well, in fact, in the previous literature, it has not done by our group, but we actually compare different types of cellulose filler. Some actually use a normal alpha cellulose as a filler in coatings, and some also use like microcrystalline cellulose, and some use a CNC. So basically looking at the performance, what we have observed, when we compare in terms of the performance, we observe that the one actually using a crystalline rather, be it for microcrystalline cellulose or cellulose nanocrystal, will produce a higher or better properties in terms of the hardness and also in terms of the anti-corrosion properties. So this is actually quite interesting for us, even though we know that the extraction of cellulose or CNC or MCC will be little, but bear in mind that in any application for coating, the amount of filler will be very little. And in fact, when we have justified in this study, a very little amount of filler, 0.5%, weight percent of CNC, even can provide a very good property. So the issues regarding on how much amount of CNC that we need to extract and need to be used for this application, actually it will be a very little amount that we need to improve the coating properties.
Yes. Okay, thank you very much for the
You're welcome.
explanation.
Thank you very much for
yes.
asking.
Very, very good. This is very interesting. Thank you very much.
You're welcome.
Yep. Thank you very much to Mr. Bedityono for the question and Prof. Haswan to the answers. And I have a question for participant, Dr. Widya Patriasari. We can ask to Professor Haswan directly.
Hello, Prof. Haswan.
Hello, how are you?
I'm fine. I think your talk is very interesting for future application. In some report, lignin is also can become as wood protection. How do you think about that? Maybe become as a filler, or what is the mechanism for as coating material? And then is there any requirement in surface area, because you hydrolyze the cellulose into CNC, maybe in the minimal requirement to obtain good properties in the coating behavior. Thank you.
Okay, so thank you very much, Ibu Widya, for this question. Well, in fact, to be honest, my background is basically on lignin. So I studied on lignin as the anti-corrosion properties. You can read the literature. So the role is possible when you talk about whether lignin can also be used as anti-corrosion properties. The answer is yes. And if we are going to include it into a coating formulation like polyurethane-based coatings or epoxy coating, it will be as corrosion inhibitors or the additive in the paint or in the coating formulation. So the other requirement will be for a normal corrosion inhibitor, it must be very rich with electrons. So when you look on the structure of the lignin itself, it's very diverse with functional groups. It has a very, I think numbers of aromatic rings. It also have heteroatoms properties. If you use lignosulfonate, it has the sulfonates. If you use a normal lignin, it also have this carbonyl and hydroxyl functionalities. So this actually can initiate the adsorption. So the essence of anti-corrosion properties is basically on adsorption. So when you have this electron-rich functionality in the structure, be it for lignin or cellulose, it can actually initiate this adsorption. So meaning that the adsorption will be the interaction between the metal surface with the lignin molecules, and this actually will stop further oxidation process of metal to become rust and whatnot. So another question that you asked in terms of these porosity, the surface area, the minimal requirement. Well, basically there's no threshold or no standard values in terms of knowing whether it is acceptable to be used as inhibitors or additive in coating. But then again, as what I have explained in the perspective of cellulose nanocrystal, it must be a slightly higher as compared to alpha cellulose itself, not too amorphous or what, because this amorphability of the lignin, or probably from these cellulose can actually retard the adsorption process. So this is actually part of the consideration that we should look. Yeah.
Thank you. I think if we convert lignin into nanolignin, I mean, is it will the surface area will also increase. So the action of the nanolignin will be better, such as CNC.
Obviously, because I think we also did another studies, not to produce nanolignin, but smaller fragments of lignin. So during the delignification process, we actually do some chemical modification during a pulping process where we dope with certain chemicals and it produces a smaller fragments of lignin. So a smaller fragments of lignin actually provide a very good antioxidant properties. So when you have a very good antioxidant properties, this actually can be a good candidate for anti-corrosion. When we talk about application as anti-corrosion, it will be a good anti-corrosion properties. So the key idea is when you have a very good antioxidant compound, then this actually can be a very good anti-corrosion property. So I mean, our assumption is that when you produce nanolignin, it can actually produce a better performance in terms of like anti-corrosion or antioxidant. Yeah. So to be honest, I think I don't think that no one has ever studied nanolignin as a anti-corrosion. I mean, in coatings or in inhibitors. So it could be interesting. I mean, if you can work on that, or maybe you can work together.
Only a little study in nanolignin for corrosion, anti-corrosion. I mean.
Yeah, very little. Yes.
Maybe for next collaboration.
Yeah, we are collaborating. We are collaborating now.
Thank you, Resti.
Yeah. Okay. Thank you, Prof. Thank you, Dr. Widya and Prof. Haswan, and maybe we can have next collaboration for this research. And okay, due to the limited time, we can only accommodate 2 questions live. And I think I will end the Q&A session. Thank you very much for Professor Haswan Hussein for his great and amazing lecture. And for the participants, we invite you all to give a round of applause to Professor Dr. Muhammad Haswan Hussein. You may use the clapping hand icon on your screen and the reaction button. Yeah, thank you. Okay, there always one more thing to learn, but today we received many from Professor Haswan Hussein. And for participant again, if you still have several questions to Professor Haswan Hussein, you can write your question on the chat box. Maybe if he can stay with us here, and maybe Professor Hussein will answer the question in the chat box as well. But no, if no, you can contact him through his email. Of course, with his permission. So we will share Professor Hussein email in the chat box after we have his permission. Is it okay, Prof?
Yes. Okay.
Okay, thank you, Prof. Haswan Hussein. And now, let's continue to our first paper presenter. And I welcome to Mrs. Nisa Nur Fajrin Solihat. I'm sure she's already with us because she is already my host partner in this session. Okay, I will read her short bio. I'm sorry, maybe someone can Mrs. Nisa, can you mute another participant? Okay, thank you. And Miss Nisa Nur Fajrin Solihat, born and raised in Karawang. She got his bachelor degree from Diponegoro University and her master from Kyunpuk National University, Korea. started working in Research Center for Biomaterial LIPI since 2015 with his interest in biomass conversion. And she has very impressive principle of life to make her life balance for her work and her family, because she admired a quote from herself that said, "You will never feel truly satisfied by work until you are satisfied by life." It's really true, isn't it, Mrs. Nisa? And now we already have her video presentation with the title is Conversion Oil Palm Empty Fruit Bunch into Reducing Sugar by Liquid Hot Water Assist Dilute Sulfuric Acid Pretreatment. And dear IT team, please play the video number 501, Nisa Nur Fajrin Solihat.
Good afternoon, ladies and gentlemen. It is my honor to present our work at First International Conference of Lignocellulose. My name is Isa. On behalf of authors, I would like to present about conversion oil palm empty fruit bunch into reducing sugar by liquid hot water assisted sulfuric acid pretreatment. Indonesia, as the world's largest producer of oil palm, is predicted to generate 11 million metric tons of oil palm empty fruit bunch SOS in the oil palm industry each year. The great quantity of OPFB SOS cause serious problem for the environment, and hence the utilization of OPFB is pivotal. OPFB has a great amount of cellulose, such as 43% of cellulose and 26% of hemicellulose, which is potentially converted into reducing sugar. Reducing sugar. The main utilization of reducing sugar is for second generation of bioethanol. However, in the conversion process, the complicated linkage of lignin with cellulose in OPFB poses a challenge. A suitable pretreatment is required to break the linkage without disrupting the cellulose structure. One promising method is liquid hot water, also known as hydrothermal pretreatment. Liquid hot water fulfill the standard condition for pretreatment, such as less corrosive, effective, and minimize cellulose degradation. According to previous results, combined liquid hot water pretreatment with acid was increasing disruption of lignocellulose matrix, yet combination with sulfuric acid has not been discussed yet. Therefore, this recent study was conducted to evaluate obtained reducing sugar and its correlation with physical and chemical alteration of pretreatment of OPFB. The use acid concentration, temperature, and time of the pretreatment were based on optimization of the liquid hot water acid pretreatment in a previous study. For the materials, OPFB was obtained from Sukabumi and sulfuric acid was obtained from Merck. The raw material was ground into small particles using a hammer mill and then sieved to obtain particle with a size of 40 mass. 5 gram sample were placed into the Teflon vessel of hydrothermal reactor with a solid liquid ratio of 1/14 for 67.17 minutes at 180 degrees with a sulfuric acid concentration of 1.5%. Determination of pH per compound and reducing sugar were obtained from liquid fraction, while the solid fraction of pulp was washed in distilled water until reach neutral pH. This solid fraction was subjected to enzymatic hydrolysis. The reaction was conducted in glass bottle. Each glass bottle was filled with 0.3 gram of the pulp, 5 milliliter of citric butter, 0.3 milliliter of sodium acid, and 30 ml of cellulose. Finally, the citric buffer was added into the glass bottle to get 30 gram of total weight. The bottles were incubated for 50 degrees Celsius for 72 hours and incubated in an incubator shaker 150 rpm. The reducing sugar yield was calculated using the DNS technique, which used a spectrophotometer at a wave number of 550 nanometer to determine the concentration of reducing sugar in supernatant. Table 1 shows chemical component of OPFB before and after pretreatment. After pretreatment, some chemical, especially cellulose component, was reduced, yet lignin content is increased. Hemicellulose is a type of amorphous structure in biomass that is easy to hydrolyze by acid. Component loss reach 71%. In this study, acid-insoluble lignin increased about 3 times after pretreatment. That may indicate exposure of lignin after degrading as amorphous cellulose content. In addition, this phenomenon showed that sulfuric acid had no appreciable effect on the lignification process. The trend of gaining value after pretreatment was also observed in extractive content due to the precipitation of low molecular weight lignin fragment and polysaccharide in the pretreated fiber. The hydrolysate was investigated, including the pH, brown compound, and reducing sugar content with the data available in Table 2. The brown compound of the hydrolysate was produced as a result of polymerization of hydroxymethyl furfural and oxidation of the phenolic structure. The pH of the liquid fraction is 0.6, where the absorbance of brown compound is 1.1. The high absorbance of the hydrolysate over 1 indicated dissolving hemicellulose into furfural and decomposition of lignin. In this study, reducing sugar content 0.13 gram per milli was measured in the hydrolysate, which may be derived from cellulose and hemicellulose. So the effect of the pretreatment on the solid fraction to the reducing sugar yield is shown in the figure 1. So according to the chemical, so as presented in the figure 1, reducing sugar per pulp of pretreated OPFB after enzymatic hydrolysis increased about 25%. From 15 into 40%. This result proves that this pretreatment has a positive effect on increasing enzymes accessibility and thus gain reducing sugar yield. Liquid hot water sulfuric acid pretreatment increased physicochemical change in biomass, such as reducing recalcitrant through disrupting the cellular matrix of biomass with lower production of inhibitor compound. According to the chemical composition result, the pretreatment removed hemicellulose and changed the chemical composition of OPFB. This finding is proven by the identification of functional group change in OPFB before and after pretreatment. Despite the fact there is no new functional group after the pretreatment, it did change the band intensity and shift the band shift the peaks band. Peaks number 1 until 3 and then until 11 and 16 until 19 are fingerprint of cellulose, while number 4 until 8, 11 until 15 are correspond to fingerprint of lignin. The obvious difference after pretreatment are diminished peak number 9. This is number 9, which associate with the CH deformation in hemicellulose and cellulose, yet peak correspond to the lignin number 12 until 14 at the range of 1,400 until 800 are more pronounced. So this is confirmed with the chemical composition result in previous slide. The comparison of same image before and after pretreatment are shown in this figure. There are significant change of OPFB structure after pretreatment. The silica bodies, red arrows here, are embedded, were attached to the surface of the fiber in circular craters, and the surface of OPFB fiber was then smooth without any cracks. On the other hand, after pretreatment, the silica body were eroded but still embedded in fiber. So this is the green arrow. So this disruption can render enzyme more accessible to penetrate, leading to the higher reducing sugar yield during the enzymatic hydrolysis process. The changing in morphological structure can also be inferred because of the loss of lignin and hemicellulose caused by pretreatment. The chemical composition of biomass influence its crystallinity degree. Lignin and hemicellulose are amorphous fraction, while cellulose has crystalline and amorphous region. Two strong peak at range of 15 until 17 degree to theta and 22 until 23 degree into theta are visible in the diffraction spectra in this figure. The crystallinity degree of OPFB is enhanced by this peak. The spectra present that peak in untreated OPFB at 15 until 17 degree is only shift, and small peak appear in the pretreated OPFB. Untreated OPFB has a higher peak at range of 22 until 20 degree to theta than pretreated one. After the pretreatment, the crystalline area reduced, but the amorphous region increased. So in the table 4, reveal that untreated OPFB has a higher crystallinity degree than treated OPFB. So we can see here it was increased from 23% to it was decreased from 23% and to 17%. After the pretreatment, the crystallinity index decreased due to the crystalline lattice disruption. For the conclusion, this pretreatment caused alteration chemical and physical properties of OPFB where it more safer on hemicellulose degradation than lignin. After pretreatment, the FTIR spectra show diminished peak intensity deformation in hemicellulose and cellulose, yet the peak correspond to the lignin are more pronounced. The crystallinity degree in XRD also show degradation, the amorphous component in the pretreated OPFB. So the crystallinity index was decreased from 23 to 17%. This pretreatment successfully disrupt the surface structure of OPFB, which open enzyme accessibility to break down the cellulose and reduce sugar. Pretreatment of PFB release up to 40% reducing sugar yield per pulp after enzymatic hydrolysis process, whereas untreated OPFB only obtains 15.6% of reducing sugar yields. So I in my presentation. Thank you for your kind attention. Good afternoon, ladies and gentlemen. It's my honor.
Okay, thank you, Mrs. Nisa, for your good presentation about conversion of pump and pivot punch into reducing sugar by acid hydrothermal. I think we already have a question for Professor Haswan Hussein. Okay, Prof.
Okay. Good afternoon to Nisa. It's a very good presentation. So basically what I have understand is that you utilize EFB and then you did some pre-hydrolysis to convert it into reduced sugar. So my question is that after you have done the dilute sulfuric acid pretreatment, did you actually check in terms of the sugar content, probably using chromatography techniques? Probably, I mean, it can give some idea whether the conversion of sugar have been done rather than using spectroscopy technique that you have mentioned using UV.
Okay, Mrs. Nisa.
Okay, so can I answer? Thank you from Professor Hazwan for the next question. Yes, actually we have to check the sugar by chromatography for the further analysis, but we haven't done yet because it's like parallel study. So we still have a more study about this topic. Thank you for your suggestion.
And then another thing is after you have done this hydrolysis, I mean the filtrate, I mean solution, is it too acidic? I mean, or it's like kind of a neutral, because after you did the acid treatment, you later do fermentation, right, with cellulase. So
yes.
If it is too acidic, then maybe it can harm the enzymes. So
yeah.
What would be your comment on this?
So for the saccharification, because the buffer citrate is about neutral, is reach 5, so I think it's not too acid for the hydrolyzed filtrate after saccharification.
Well, thank you. All the best to you.
Okay, thank you.
Okay, thank you for Professor Hassan for the question and Ms. Nisa for the answer. Sorry, due to the limited time, maybe I will end the Q&A session. And thank you again for Mrs. Nisa Nur Fajrin Solihat. It's very great and interesting topic. And we will have to move to another presenter. Now we're going to the next presenter. I welcome to Dr. Ihsan Gusvenrivo. I think he already with us. Maybe you can turn on your camera, Dr. Rivo. And I will read her short bio. Okay. Dr. Ihsan Gusvenrivo, born and raised in Padang Panjang, West Sumatera. He earned his bachelor degree from Jayabaya University, master degree from University Sains Malaysia, and doctoral degree from Kyoto University, Japan. Joined with Research Center for Biomaterials LIPI since 2005. With his interest in insect pest control and biodeterioration, he developed some biological control agents from natural resources, such as plants and fungi against urban and industrial pests. And it's very interesting research. So if you have any trouble with termite in your house, maybe you can ask Dr. Rivo to solve your problem. And now we will listen the video presentation from Dr. Rivo about antivedant activity of the mixture of wood vinegar, neem oil, and biosurfactant against Spodoptera funiperda. Dear IT team, please play the video number 502, Arif Heru Ihsan Gusvenrivo.
Hello everyone, I'm Ihsan Gusvenrivo from Research Center Biomaterials, National Research and Innovation Agency, BRIN. Today, I will present our research finding with the title Antivedant Activity of the Mixtures of Liquid Smoke, Neem Oil, and Biosurfactant against Spodoptera funiperda. Spodoptera funiperda, or fall armyworm, is the pest that attacks more than 80 plant species, including corn, rice, sorghum, sugarcane, vegetable, and corn. The species of armyworm, or Spodoptera funiperda, can result in a very significant loss of corn yield. This pest is first discovered in Central and West Africa in early 2016. The fall armyworm, which was first discovered in Indonesia in 2019, has damaged maize crop with heavy attack rate in West Pasaman District, West Sumatra. The life cycle of this pest varies depending on the season, which is 30 days in summer and up to 90 days in autumn. In fact, the control of Spodoptera funiperda has not been maximized and only relies on chemical pesticide, in which these pesticides are feared that long-term use can damage the environment and endanger humans. Therefore, alternative materials of pesticide that are more environmentally safe and effective are still needed. It has been well known that biopesticide or pesticide derived from plant extract and microorganisms can be alternative control to control funiperda. Prianto et al. In 2018 reported that active compounds from neem and wood vinegar exhibit high potential to control pests of the genus Spodoptera. Neems, or Azadirachta indica ajus, contain several active compounds including azadirachtin, nimbin, and salanine, while the main component in wood vinegar are organic acid and phenolic derivatives. Therefore, this study aimed to evaluate the effectiveness of biopesticide formulations from a mixture of neem seed oil, biosurfactant, and wood vinegar against Spodoptera funiperda. In this study, we used neem seed, rice husk, and commercial biosurfactant of castor oil polyoxyethylene ether as well as the Spodoptera frumiperda that was obtained from Research Center of Biology. The preparation of neem oil used the cold press method. Neem seeds are used in air-dry conditions with moisture content below 15%. The pressing process uses a screw press machine at the rotation speed of 120 rpm. The produced oil was then collected. Wood vinegar was made from rice husk. It was burned in the carbonized reactor and heated at the temperature 400 degrees C. The smoke generated was then condensed and collected. Furthermore, wood vinegar was separated to get tar as byproduct. The preparation of emulsions. Neem oil around 1 to 3 milliliter was added to the surfactant and homogenized for 10 minutes. Furthermore, the wood vinegar was prepared in various volumes according to the proportion in the emulsions. The emulsions were composed of neem oil, wood vinegar, and surfactant with this ratio. Wood vinegar and a mixture of neem oil and biosurfactant were homogenized with the homogenizer at speed of 6000 rpm. For the antioxidant activity, we use the Spodoptera frumiperda that have been rare at room temperature 25 degrees C with the relative humidity 70% and feed with corn leaf. The antioxidant activity using the choice feeding test method with a feed size of 1.5 times 2 cm corn leaf. The corn leaf were dipped in the emulsions for 3 seconds and dried in the air. Then, each leaf sample was placed in the plastic container, which was then added to the 13 star of Spodoptera frumiperda larvae. Observation was made after 24 hours with 7 replications, and the area consumed was calculated, and the antioxidant activity was calculated using the formula. This is the composition of emulsion formulation that has been used. The results said that antioxidant is the condition that inhibits the pest to consume the treated feed, in this case corn leaves. These conditions are caused by the composition of chemical compound in the biopesticide formulations derived from a mixture of neem seed oil and wood vinegar, in which this biopesticide can disrupt the sensory and or affect the insect central nervous system, which can affect the feeding process. In this table shows the percentage effectiveness of biopesticide formulations from a mixture of neem seed oil and wood vinegar. In this study, there were 4 groups of different biopesticide formulations, namely group A, B, C, and D, with concentration of neem seed oil were 10%, 20%, and 30%. Formulation A was biopesticide formulation that used biosurfactant with the concentration of 10%, while formulation A1, A2, and A3 used 10%, 20%, and 30% of neem seed oil respectively. Based on the result, the highest effectiveness up to the third were obtained from formulation A3, A2, and A1. The formulation B used 12.5% of biosurfactant, and the formulation C, where the formulation C used the similar concentration of biosurfactant with the formulation D. This data suggested that the antioxidant effectiveness was affected by the concentration of neem seed oil. In formulation D, tar of wood vinegar was added. The result shows that the formulation D3 shows the highest antioxidant effectiveness, followed by formulation D2 and D1. This phenomenon may be addressed to the pungent smell of phenol from wood vinegar, tar that has an important role as a repellent, causing the fall armyworm to be disliked to consume the treated corn leaf by biopesticide formulations. In this table shows the result of antioxidant activity analysis. Statistical analysis shows that the treatment of biopesticide formulation was significantly different at the 95% confidence level. Duncan test shows that the same letter indicate not significantly difference. The result clearly shows that formulation A3, C3, D1, D2, and D3 exhibit high antioxidant activity. The treatment in the group A with 10% biosurfactant, 30% neem oil, and 60% wood vinegar shows comparable effectiveness with 12.3% biosurfactant concentration and reduced wood vinegar in formulation B. The various neem concentrations 10 to 30% with the conditions of 1% tar in the treatment D. This result constituent component in the formulation can substitute each other. However, A3 was ideal because it generated high effectiveness, had low biosurfactant, and did not use a tar. Therefore, biopesticide formulation with 10% neem seed oil and addition of tar show higher antioxidant activity compared to biopesticide formulation made from 20% neem seed oil without the addition of tar. Smoked tar is fraction that is insoluble in water, highly acidic, and has higher specific gravity than liquid smoke. The zeta potential measurement of emulsion formulation had a value between 31.7 to 47.5 MV, which indicate a good emulsion stability after 7 days. Formulations A3 had the best zeta potential value, which show the best stability in the formulation with 30% neem oil compositions, 60% liquid smoke, and 10% biosurfactant. The zeta potential distributions of the emulsions of formulations A1, A2, and A3 is shown in the figure. Based on their distributions, the A1 and A2 had the least variations, while the A3 had the highest variability, but the A3 showed the best emulsion stability. However, the droplet size in the emulsions of the A3 shows the largest size compared to that of the A1 and A2. As the conclusions, the composition of neem seed oil contained in the formulation shows a strong influence on antioxidant activity. The compositions of the formulation that had high and optimal antioxidant activity was found in the formulation containing 30% neem seed oil, 10% biosurfactant, and 60% liquid smoke, and antioxidant activity by 83.86%. Thank you for your kind listening.
Yeah, okay, thank you for Dr. Rivo for your nice presentation about the biopesticide from the mixture of wood vinegar, neem oil, and biosurfactant for Spodoptera funiper. It's very interesting, so I will open the Q&A session for the participant. Again, if you have a question for Dr. Rivo, you can directly say by unmute your microphone, and don't forget to open your camera as well so we can see your beautiful or your handsome face. Do you have any questions? Okay. Please, Mr. Dedi Triyono.
Thank you very much. I would like to ask about this study using three material: the lips oil, liquid smoke, and then biosurfactant. I wonder why did you determine these three material to be studied? Do you have some specific reason or something? And maybe for the additional question about the lips oil, maybe do you have any information about the yield of the lips oil extracted by the cold press like you studied? Thank you. Maybe that's all.
Should I answer directly?
Yes.
Yes.
All right. Thank you. Thank you very much for your questions, Mr. Dedi. Maybe if my answer is not good enough, there's another. The first author is also attend this meeting, so maybe he can add some more answer later on. So for the first questions, why we choose these three materials? First of all, the neem seed oil actually we already tested before against several insects such as Spodoptera litura and another insect. But when it's standalone, when we add some more the liquid smoke that also reported also have the have an impact to the insect. So we try to combine the neem seed oil with the liquid smoke, but because of these two materials cannot dissolve together, so we need to use the surfactant to dissolve both of them. The first time we tried to use the chemical surfactant, but when we apply it to the plant, so there's a negative impact showed up that the plant is get burned when we use the chemical surfactant. That's why we try to use the biosurfactant. So that's the story behind we choose these three kind of materials. And for the second questions, the yield is actually I think it's around 30%, if I'm not mistaken, from the seed itself. Mr. Heru, if you are in this room, maybe you can help me to answer about the yield of the neem seed oil.
Okay, thank you for the question. The yield of the neem oil is about 12 until 15%.
Sorry?
15. 1 5.
Oh, 1 5. Okay.
Okay, thank you, Mr. Heru.
So maybe I would like to confirm about this pesticide is compounded by three kind of material, which is neem oil, and then you want to combine with the liquid smoke because there is difficulty of the mix to make some suspension or emulsion. You require the support from the biosurfactant. Okay, maybe some additional question. If this pesticide can be applied, so do you measure about how much is it, because maybe if we use the pesticide in a very large farming area, it will require a lot of material to be used. So do you have some idea about this one, or maybe another study? But it's not no need to be answered now. Maybe maybe I think it's, some suggestion for me for you.
Okay, thank you very much, Mr. Dedi. Now, actually, for the economic study, we already tried to calculate the cost of this biopesticide. So, but it's still still under study. Thank you.
Okay, thank you for Mr. Dedi Triyono for the question, and also for Dr. Ihsan Gusfenrivo and Mr. Heru for the answer. It's very nice and interesting topic, but due to the limited time, we have to move to our third presenter. So stay safe and healthy for you and your family as well, Dr. Ivo. Now we are in the third presenter, or the last presenter for this morning session before we have lunch break. And I welcome to Professor Ahyar Ahmad. I hope he is already here with us. Okay. Hi, Prof. And I will read her short bio. Professor Dr. Ahyar Ahmad, born and raised in Bima, West Nusa Tenggara. He earned his bachelor degree in chemistry from Hasanuddin University, Makassar, and doctoral degree from Miyazaki University, Japan. He is a lecturer as a professor, of course, and research in Hasanuddin University with his interest in biochemistry and molecular biology, including natural products, as drug materials and biomass functions. He also has many publications for his work in referred journals. So, Professor Ahyar, it's our honor to have you here. Now we will listen the video presentation from Professor Ahyar Ahmad, which represent with his student, I think, about the production of bioethanol from Penicetum purpureum, sumach leaves of the simultaneous fermentation system by using Clostridium acetobutyricum. Dear IT team, please play the video for Professor Ahyar Ahmad.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. It is an honor to have the opportunity to present our research. Today, I'm very excited to be here and be the presenter. As you can see on the screen, our research topic is production of bioethanol from Penicetum purpureum sumach of the simultaneous fermentation system by using Clostridium acetobutyricum. This research is a collaboration authors, as you can see on the screen. Now, let me move to introduction of our research. Today, with the higher price premium that resulting from the depletion of world oil and petroleum consumption that continues to increase also can trigger global warming. So I think the solution is renewable materials. Is an bioethanol. As we know, bioethanol is a biochemical fluid that can be obtained from the fermentation of sugar from carbohydrates that using the microorganism assistance continued with the process of distillation. There are several benefits of ethanol. That is, it can be made from plants, and in gasoline, it is a high quality and high octane, can be reduction of pollutants and GHG emissions. Ethanol is produced by fermentation with the aid of microorganisms, referred to as bioethanol. Then take a look of these feature approaches of bioethanol. One alternative, a raw material for bioethanol production is the cellulosic biomass. In Indonesia, cellulosic biomass is an abundant natural resource and cheap, which is potential to support commercial production industry fuels like bioethanol. It can be obtained from agricultural waste. One of agricultural waste that is able to produce raw material for bioethanol is white leaf grass. This is the picture of white leaf grass that is also known as elephant grass in Indonesia. Today, the only white leaf grass used as cattle food, sometimes even just considered a nuisance plants. Penicetum purpureum sumach is white leaf grass in Indonesia, has a high cellulose content that is report 40.85%, which can be used as an ingredient producer of ethanol. So the objective of the study are first to investigate a conversion value of cellulose of white leaf grass as the material for bioethanol production through the process of the simultaneous fermentation system by using Clostridium acetobutylicum bacteria. Second, determine the optimum condition of fermentation. And then finally, to know the production of bioethanol from white leaf grass based on condition optimum of fermentation. Now this is the material and methods. This research was conducted at the Bioprocess Laboratory, Department of Chemical Engineering, Polytechnic State Ujung Pandang. And then the study is purely experimental with states as follows. You can take a look the schemes on the screen. The first step in this process is pretreatment process. That is prior to fermentation, accompanied by removal of lignin that followed that can be toxic for fermenting microorganism. That in this method, the process using sodium hydroxide 5 until 7% and continued with bleaching with hydrogen peroxide 3%. And then the next step is fermentation. So we're using SSM method. In determine optimum condition of fermentation based on cellulose with leaf grass, the experiment using various pH. They are pH 5, 5.5, 6.5, 7, and 7.5. That pH is adjusted by buffer phosphate and continued to fermentate in a second incubator for various days from day 2 to day 14. After we know the optimum condition, we continue to know the production of bioethanol based on condition optimum of fermentation. Now, result and discussion. In this method, after pretreatment, we know that the cellulose has been separated from the lignocellulose complex and increased its amorphous fraction. Thus, this biopolymer is ready for its hydrolysis into glucose units or even for its direct conversion into ethanol. In simultaneous fermentation on this method is also known as direct microbial conversion, and it integrates maximum biotransformation of biomass into ethanol in a single reactor by Clostridium acetobutylicum. That is cellulose production, cellulose hydrolysis, and fermentation are accomplished in one step, then followed for production process in optimum fermentation. Now let's move to double effect of time and pH fermentation versus bioethanol content. As you can see on screen, from the experiment using various pH from day 2 to day 14, we come up with the result that all of pH has the highest level of bioethanol on day 10. This is the graphic of the previous table, determination graph of optimum fermentation condition of pH and fermentation time. All treatments on day 10 to day 6 collect phase lag that increase of bioethanol are very slow, in which the microbes are still adjusting to environmental conditions. And on the day 8 to day 10, the called exponential phase, that during this phase, the increased cell growth rate is proportional to the concentration of cell at the time, which is bioethanol content at day 10 is proportional. And then at day 12, the bacteria with a stationary phase, which shows the bacteria is not working optimal stationary, and at day 14, concentration of ethanol products has been decreased and relatively constant. That means this is the deep phase of the bacteria. Let's move to the table of effect of pH fermentation. We compare all of the pH at day 10 in one table, and then the result is that pH 6.5 has the highest level of bioethanol than other pH. At this pH, the rate of growth or reproductive cell reaches a maximum point. Then there is growth exponentially. Now this is the graphic of previous table. We know that the optimum pH fermentation is on pH 6.5. In production of bioethanol process was dehydrated by distillation process, and it was obtained at as much 22.5 milliliter, and through refining process. After purificating through distillation and drying with dinatrium sulfate, the sample was analyzed with the same method. This is the graph showing the relationship of ethanol concentration standard with a value of 1 and 1 at least. This is from the equation. We know that the sample obtained as sample rate is 96.42% of bioethanol production after purification. So after all the experiment, we have concluded, first, the elephant grass, Penicillium purpureum squamous, can be converted into bioethanol with bioethanol level is 15.60%, respectively after 10 days of fermentation. Second, the research result reveals that the optimum condition of fermentation was obtained on the pH of 6.5 in 10 days fermentation, with bioethanol levels is 15.60% respectively. And then finally, the conversion value of the 11 grass, that is in every 1 kilogram of cellulose, can produce bioethanol 33.30 grams, that is grading 96.42% after purification storage. Well, that's all for now. Thank you for your great attention. I hope you have an amazing day. And Assalamualaikum warahmatullahi wabarakatuh, and good morning.
Okay, thank you for Professor Ahmad for your interesting presentation. So I will open the Q&A session for the participant. Again, if you have a question, okay, from Prof. Ais Hermiati, please, you can ask directly your question to Prof. Ahyar Ahmad.
Thank you very much. I just wondering, yesterday I also follow the presentations, I think from the same team. I wonder what is the difference between this study and the study that you presented yesterday, because I notified that you use this the same you use elephant grass yesterday and today also, and the process is also simultaneous saccharification and fermentation, and you use the same bacteria, if I'm not mistaken. Just wondering about that. Thank you.
Thank you for your question and suggestion. The different contents of this study compared yesterday's study. This study we use material for cellulose researchers from wild type of elephant grass leaves, but yesterday presentation we use elephant grass with modified genetic elephant grass stem elephant grass, not leaves. this point, the different of the study with yesterday presentation. This wild type of elephant grass, but leafest, and yesterday result of modified genetic modified to result mini elephant grass and leafest for cellulose resources. Thank you.
Okay, thank you.
Okay, thank you. Maybe the last question from Miss Maulida. Just quick question, I think. We cannot hear your voice.
Hello, can you hear me?
Yes, I can hear.
Okay, thank you very much. My question is for the third presenter and also maybe for Professor Ahyar. I just wondering why did you use bacteria instead of yeast? Because it takes a longer time if you use bacteria than yeast. That's all. Thank you.
Thank you for your question. The advantage of this bacteria, Clostridium acetobutylicum, for produce the bioethanol can simultaneous to hydrolysis cellulose to glucose and simultaneous to fermentation glucose to produce bioethanol. But if yeast just not simultaneous, but just different step of hydrolyze cellulose to glucose, and just yeast can fermentate glucose to produce bioethanol. This point of different of bacteria, especially Clostridium acetobutylicum, to produce bioethanol. We can produce simultaneous process, not different step to produce bioethanol.
So you mean that the bacteria can hydrolyze the cellulose into glucose?
Yes.
But you use cellulose also in your experiment?
Yes.
Why did you use cellulose if the bacteria can hydrolyze?
Because this novelty of strain of bacteria Clostridium acetobutylicum can produce the cellulose enzyme maybe to hydrolysis of cellulose to produce glucose, but yeast cannot hydrolyze this cellulose.
So you combine the cellulose and bacteria to hydrolyze the cellulose to glucose, right?
Yes.
Okay, thank you.
Thank you for your question and suggestion.
Okay, thank you. I'm sorry, maybe I think that's the last question for this session. Thank you for Professor Ahyar Ahmad. It's a very interesting topic. It's our honor to have you here. Stay safe and healthy for you and your family as well. And now I think we already have all of the presentations from our presenters for this morning session. Thank you very much for our invited speaker, Professor Dr. Muhammad Hassan Hussein from University Science Malaysia, and the presenters as well. It is very interesting and very instructive session in such a joyful environment, I think. And thank you very much for joining with us in our seminar. And now the next agenda is lunch break. So we have about 45 minutes to lunch and afternoon break. And for the afternoon session, we will start at 1:30 p.m. So you can join with us again in that time for the afternoon session, because we still have 3 presenters, including me. So for the next session, Mrs. Nisa will be your moderator. Okay, we are finished for this session. Now you can just stay in this room till we open again, or you can join to our other room. Or maybe I think it's already finished, yeah. See you after lunch break. Assalamualaikum warahmatullahi wabarakatuh.
Hi, good afternoon, ladies and gentlemen. My name is Nisa. As a moderator in the station after lunch break, I hope you enjoy your lunch and get ready for listening the next presentation. Now, let's continue to the next presenter. I welcome Ms. Resti Herlina. I hope she is still here. I believe she is still here and turn on her video. She will give presentation about chemical bond analysis of activated carbon from oil palm was using FTIR and Raman spectroscopy. So for the short bio, she is born and raised in Jakarta. Resti earned her bachelor degree from Bandung Institute of Technology and master degree in sandwich program from Bandung Institute of Technology and University of Groningen. So she started working as a researcher in Research Center for Biomaterials LIPI since 2019, and she has a beautiful word here. Don't run behind success, follow behind excellence. Success will come all the way behind you. So we will start for the pre-recording video. IT team, please play video for 504.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone, ladies and gentlemen. Today is my pleasure to participate in this conference, the first international conference of Lignocellulose in conjunction with the 10th International Symposium for Sustainable Humanosphere 2021. And I am Resti Marlina from the Research Center for Biomaterials, Indonesian Institute of Sciences, that now become the National Research and Innovation Agency. Will present my research topic entitled Chemical Bond Analysis of Activated Carbon from Oil Palm Waste using FTIR and Raman spectroscopy. This research was conducted in collaboration with our students from Brawijaya University and Bandung Institute of Technology. Here is the outline of my presentation. First, I will give brief introduction related to the lignocellulose biomass. Second, I will explain how we produce the activated carbon from biomass. Then I will describe the result of our sample using FTIR and Raman spectroscopy.
Recording in progress.
And conclusions. Starting with general issues in our Earth, global warming has become a critical issue for our environment, followed by the limitation of fossil energy, environmental pollution, hazardous and poor management waste. So that's why new and renewable energy has been a tremendous issue for our environment, and many researchers put their effort to find these green and eco-friendly resources. Biomass has been a promising energy resources that can be a solution for our environment. Most of biomass resources are lignocellulose biomass, which according to the Renewable Energy Directive, European Union, lignocellulose biomass is the biodegradable fraction of products, waste and residues from biological origin like agriculture, forestry, and any related industries. And most of lignocellulose material or lignocellulose biomass consists of cellulose, hemicellulose, lignin, and any other extractive component. Then one of the lignocellulose biomass that we use in this research is oil palm waste. Why do we use oil palm waste? First, it's because the oil palm has become one of the largest export commodities in Indonesia, with the plantation areas about 15 million hectares and the productions about 49 million tons per year. And the second, the fact that from oil palm plantations, only 10% is used as crude palm oil or CPO, and 90% are plantation residues. And from these plantation residues, we focus on two kinds of oil palm residues, that is the oil palm cell or OPS and oil palm antifreeze punch or OPEFP. And for the chemical content of this material, you can see in the slide that oil palm cells dominated by lignin, while the oil palm empty fluid bunch dominated by cellulose. However, both of these materials have a high potential to be used as activated carbon in order to increase the added value of this material. And as I said earlier, in this research we utilize oil palm empty fluid bunch and oil palm cell to increase the added value of this material become activated carbon. Activated carbon itself is a black material with a very high carbon element and has many pore structures and high surface area. With these pore structures and the high surface area features, activated carbon can be applied in many fields, including water purifiers, fertilizers, drug and catalysts, personal and healthcare products, as well as material in energy storage devices such as electrodes in supercapacitor, batteries, and carbon paper for fuel cell. And now this is FTIR spectroscopy that we use to analyze and see the chemical bonding in our material. We use Perkin-Elmer FTIR Spectrum 2, as you can see in the slide, and this method can identify compound or functional group of material in infrared region. This is the configuration of FTIR instrument, and this is the example of absorption curve that produced from the measurement. It is shown that for certain wave number, it will identify the certain compound or functional group as well. Complement with FTIR spectroscopy, Raman spectroscopy has almost the same function actually. It can detect the chemical compound of material, but principal work of Raman is based on elastic scattering, where the capture of this Raman scattering will produce a spectrum that can be used to identify molecular bond in material. And this is the scheme of our synthesis method. We use the hydrothermal pyrolysis method with potassium hydroxide activator to make activated carbon. And main process in this synthesis is hydrothermal carbonization process using autoclave, the activation process using potassium hydroxide activator, the pyrolysis carbonization in furnace at 800 degrees C, and the neutralization sample using hydrochloric acid and the water. And here is our approximate analysis result. This picture shows that the material's transformation from raw to the hydrocharged and activated carbon. From our experiment, the yield of activated carbon from oil palm cell has almost 3 times higher than oil palm empty fluid bunch due to its density and lignin content. For water content, activated carbon material from oil palm cell has a higher water content than oil palm empty fluid bunch. It can be happen because the formation of pores in oil palm cell is relatively more difficult than oil palm empty fluid bunch, so that the fewer pores tend to be more difficult to evaporate water molecules in the sample. And for the S content, activated carbon from oil palm empty fluid bunch has a greater S content at 6.5% compared to the oil palm cell, which is related to the cellulose content in oil palm empty fluid bunch material, because high cellulose material is more easily degraded at low temperature than high lignin content. And the last, from the result of proximate analysis, we can be said that the activated carbon from oil palm empty fluid bunch has met the SNE standard for technical activated carbon. Next is the result of FTIR analysis. From this spectra, it can be seen the process of converting this biomass from raw material to activated carbon. And for the hydrocharge spectra in the red lines, we can see that the absorption peak decrease, which indicates a conversion process in hydrocharge material from the raw material. And for the activated carbon spectra, the black line, there's no significant absorption curve, because the chemical bonds in activated carbon are not detected in IR mode, but can only detect it in Raman mode. And the prominent peaks in the green area is predicted to be contribution from chemical bonds in cellulose compound. From the result of FTR curve, it can also see that the range between 4,000 till 1,500 is a functional group area indicated by the presence of OH bond, CH bond, C-double-O bonds, and C-double-C bonds, which derived from the cellulose compound, while the range between 1,500 till 400 is a specific fingerprint area on certain materials where we can identify the presence of CH bond, C-double-O bonds, and the deformation of the phenol group from tertiary alcohol to primary alcohol. And this is just a summary table of the chemical bonds identified in our FTR spectra, where the bonds that appear are contribution of the cellulose, hemicellulose, and lignin compound. And also this is the visualization of the bond. Next is the result of Raman analysis. The Raman spectra shows the characteristic curve of the carbon material with the appearance of D-band and G-band peaks. The D-band itself is a peak that represents the structure of defect in the carbon material from the CC vibration atom in the carbon change, while the G-band is a peak that represents the graphitic structure of the carbon material derived from the CC vibration atom in the carbon ring and change. Specifically for biomass, the D-band can be associated with the long aromatic ring structure of the carbon, and G-band is associated with the short aromatic ring system. And go to the deep analysis, we do some fitting or the convolution from this Raman spectra for D and G peak to see a comparison of the intensity of D and G peak. And from that, we can determine the degree of carbonization structure in our activated carbon. Fitting was done using Origin software. From the fitting, we can get the ratio of ID and IG has almost give us the same value at 0.93, which is close to 1. So we can say that our material has a good degree carbonization, or the structure of aromatic change are quite balanced with the structure of the short aromatic change. And finally, we can conclude that the activated carbon material has been successfully produced and meet the SNE 63730 standard for technical activated carbon, where the activated carbon yield from the oil palm cell has a higher yield than oil palm antifreeze branch. And from the FTR spectra, we can see the degradation mechanism or conversion of lignocellulose biomass into activated carbon material. And the last, the Raman spectra show the presence of D and G peaks as a fingerprints of carbon material, where the ID and IG ratio gives a value around 0.93, which indicates that our sample has a good degree of carbonization. Okay, I think that's all of my presentation. Thank you for your attention, and I'm quite happy if you have any questions. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for Mr. Resti for nice presentation about chemical bond analysis of active carbon from oil palm waste. So we are now in QA session. If you have a question, please raise your hand by emoticons and unmute your microphone. So do we have anyone here? Have a question? Okay, I want to ask one question actually. So in this study, you compare between FTIR and Raman spectra, right? So So why did you compare between of two instruments? Because as I know, both of them have a same function, just like for analyzing the functional group of the substance. And also in the Raman spectra, you show that BNG band. So can we also analyze it by FTIR?
Okay, thank you for your question, Mrs. Nisa. So my voice is clear, right?
Yeah.
Okay, so yeah, to answer your question, I use the FTIR and Raman because actually there's what's called a selection rule between the IR spectroscopy and Raman spectroscopy. So not all of the chemical bond can be detected by IR spectroscopy, and also for the Raman spectroscopy as well. So for example, for the IR spectroscopy, the molecule that can be detected for the IR spectroscopy is the molecule that has a dipole moment. And for the Raman, dipole moment is not very important, so we can detect it in Raman mode for another bond. For example, for water molecule is 2HO that has a dipole molecule that it can be detected by IR spectroscopy, but not in Raman spectroscopy. And actually, for the Raman spectroscopy, I think all of the carbon material should be characterized by Raman spectroscopy because they don't have a dipole molecule because the bond is only CNC, right? And they are not have a dipole molecule, so we can we can detect it in Raman spectra. I think I hope it answers your question.
Yes.
Okay.
Very clear answer. So we have another question from Ms. Fahria. So you can unmute your microphone, please.
Yeah, thank you very much. To Mrs. Resti, as I know, activated carbon have special characteristics such as pores, and the pores can be effectively active to be an adsorbent. Depends on what you want to activated carbon to use for. So in your study, what do you want the activated carbon that you produce to be used? And is there any difference with activated carbon in the market?
Okay, thank you, Ms. Fahria, for the question. Actually, my activated carbon is specialized for the electronic energy storage devices for the future application. So that's why in the synthesis of the carbon, we use the hydrothermal and pyrolysis method. The hydrothermal method, we aim to have or we want to have a good precursor for the activated carbon. So because for the energy storage application, we need a mesopore to get the good conductivity for the application. And for the commercial one, I think many pores can be produced, like macropores, micropore, nanopore, or mesopore, and maybe it can be used as a main application, like for absorbent, water purifier, and etc. But maybe for the commercial one, they only use the pyrolysis method. I think because I'm quite familiar with that method to be used as activated carbon, but for the energy storage application, we focus to produce more mesopores, mesopores. So we try to use the hydrothermal method and then the pyrolysis method for our synthesis. I hope it can answer your question, Ms. Fahria.
Okay, thank you very much for the explanation. That's enough for me.
Okay, thank you for Ms. Fahria and Ms. Resti. Now let's continue to our next presenter. I welcome Ms. Santi Ratnakomala. I wish she's still here and turn on her camera. For the title of presentation is application of lignocellulose producing strain Icon-Lig to decompose plant waste material. Ms. Santi Ratnakomala was born in Pontianak, West Borneo, Indonesia. She obtained her first degree in biology from Padjajaran University and continued her master and doctoral degree at ITB Graduate School, Bogor. Previously, she was a researcher in the field of microbiology in Research Center for Biotechnology. Then, in 2020, she moved to INACC at Research Center for Biology with the major fields of exploring the actinobacterial diversity in Indonesia and potential use of this microbe. We will hear the presentation of Ms. Santi. IT team, please play a video number 505.
Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. It is my great pleasure to be here to share our study on the composition of biomass with all of you. My name is Santi Ratnakomala from Research Center for Biology. First, I will present the presentation with the title Application of Lignocellulose Producing Strain Actinomycetes to Decompose Plant Waste Materials. This presentation will divide it into 4 steps, that is, introduction, material and methods, results and discussion, and conclusion. As introduction, it is widely known that Indonesia is an agricultural country, which produces a lot of biomass waste from its agriculture. Among them are leaf litter, rice straw, and corn stalk. The abundance of biomass waste with the activity of microorganisms, humidity, and control condition can be degraded into compost. What is composting and compost? Compost is the transformation of organic material through the composition into a biologically humus-rich substances suitable for growing plants. Invertebrates and microorganisms helps in this transformation. Compost is organic matter that has been completely decomposed. It will improve the ability of the soil to accept and store water. It also increases the activity and number of soil organisms. Compost can reduce the need for supplemental chemical, and adding organic matter to soil also help to protect water quality and the environment by limiting chemical runoff into the watershed. Naturally, organic matter will decompose and can be degraded into compost or humus takes a long time, between half to a year. However, the composting process can take place more quickly by adding an activator or compost inoculum. This activator is a consortium of microorganisms that function to accelerate the composition of organic matter in the compost. This study aimed to evaluate the effect of adding a mixed culture or actinomycete, which have lignocellulosic activity during the composting of plant waste biomass, such as eucalyptus litter, rice straw, and corn stalk waste as substrates. To utilize the abundant lignocellulose biomass waste into compost, lignocellulose degrading enzymes are needed, such as cellulase, silanase, and mannanase enzyme. Therefore, actinomycetes used as compost bioactivator are screened for their ability to produce this enzyme. The actinomycetes were cultured for 4 days on medium containing specific substrates, that is locust bean gum, CMC, and birchwood villan. then incubated at room temperature for 4 days. Plates were then flooded with 0.1% Congo red for 15 to 20 minutes, then washed with 1 molar NaCl and kept overnight at 5 degrees. Bacterial colony exhibiting clear zone against red color of non-hydrolyzed media were considered enzyme producer manganese, cellulase, and silanase enzyme. For composting eucalyptus leaves, corn stalk, and rice straw, the following steps are carried out. We are using raw material from leaf litter of eucalyptus, corn stalk waste, and paddy straw. And for inoculum actinomycete, we made mixed culture of ID6455, ID6479, and ID6279. And then added about 20% volume per weight of mixed inoculum to each treated biomass. And then we incubate the compost pile for 2 months, turning the compost pile position every week and sampling for analysis for each 1 month of incubation. The humidity in the compost pile were maintained for 60%. This is the composting process. Some analysis was carried out during the composting process. About half kilogram of compost samples was taken out from compost piles during the 1 and 2 month incubation time of composting. The compost samples were then drying and grinding for physical analysis, chemical analysis, and also for microbiological analysis. The results of testing on the ability of actinomycete to produce various enzymes show that 2 isolates, namely ID6455 and ID6479, were able to produce cellulase, silanase, and manganese enzymes with good activity, which resulted in clear zone between 2.7 to 4.4 cm. Meanwhile, the isolate of ID6279 was able to produce manganese and cellulase enzymes. The 3 isolates belong to the genus Streptomyces. The tables 2 and 3 describe the minimum requirement of organic fertilizer from Ministry of Agriculture Regulation 2006 and carbon to nitrogen ratio in various materials. Table 4 shows the chemical and biological analysis result of eucalyptus leaf compost during the 1 and 2 months incubation period. Mixed actinomycete inoculum did not increase much mineral content, micronutrient, or total phosphorus and total potassium of the composted eucalyptus leaves. Eucalyptus leaves are difficult to degrade, probably because this plant contains essential oil that can inhibit the growth and activity of the most microorganisms. Table 5 is about the composition of eucalyptus leaf residue with inoculation mixed culture actinomycete. The final product of the compost eucalyptus leaves containing mixed culture inoculum showed a little higher organic matter than the uninoculated control. This table shows the chemical and biological analysis result of cornstalk compost. From our observation, total N levels increase with incubation time. The addition of mixed culture actinomycete increased total N levels. This means that the cornstalk biomass decomposition process took place more effectively with the addition of actinomycete cultures. Observation on bacterial population during composting cornstalk can be seen the adding mixed culture inoculum actinomycete decrease the total number of bacteria and actinomycete after 2 months of composting. And this is probably because of the decrease in nutrient required for microbial growth. Table 7 is about the composition of cornstalk compost without and with inoculation of mixed culture actinomycete. The final product of cornstalk compost containing mixed culture of inoculum show higher water content and decrease in organic matter compared to those the uninoculated control. Table 8 show the chemical and biological analysis results of rice straw compost. Rice straw compost pile with the addition of inoculum showed an increase in the number of actinomycete population after 2 months of composting. It happens because the enzymatic activity that occurs in a compost pile has taken place. The lignocellulose enzyme produced from actinomycete consortium have degraded organic matter, consists of cellulosic substrate into glucose monomer and are used to increase the actinomycete population. This table about composition of rice straw compost without and with inoculation mixed culture actinomycete. The final product containing mixed culture inoculum show decreased organic matter than the uninoculated control. Rice straw compost with inoculum show reduced fiber content, protein, and energy more higher than the uninoculated control piles. This figure show the physical change observed during 2 months of composting period. Number 1 is eucalyptus leaf compost. Number 2 is cornstalk compost, and 3 is rice straw compost. A is control, B is 1 month composting, and C is 2 months of composting. You can see that the compost from cornstalk is more effectively degraded in 2 months of incubation period. In conclusion, I would like to emphasize that this study involved potential screening of actinomycete, selected 3 isolates with cellulolytic, mannanolytic, and silanolytic activity. Isolate of ID 6455 is for cellulolytic actinomycete. ID 6479 has silanolytic activity, and ID 6279 is for mannanolytic actinomycete. All the strains also have activity at least for 2 more enzymes. The mixed inoculum for biomass composting show that cornstalk quickly degrade than rice straw and eucalyptus leaves. Actinomycete strain can survive in the elevated of pH and temperature condition as much as bacteria and fungi. Their specific consortia can single-handedly produce a key enzyme for composting. Lastly, I would like to express my sincerest gratitude to the Japan Society for the Promotion of Science, JSPS, for partial funding of the publication fee. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for Ms. Santi. Very nice talk about the composition plant waste into compost. So we are now in Q&A session. If you have question, please raise your hand in the reaction button and unmute your microphone. Do we have anyone here? Okay. Mr. Dedi, please unmute your microphone and directly ask to Ms. Santi.
Thank you. How are you, Santi?
Fine. Okay.
I just would like to ask about maybe some simple question about this composting material. Do you have any idea what will you do after the composting of this material? These three kind of. I watched that the eucalyptus is difficult to be composting, but for the corn stalk and rice straws getting better. Is it still possible for the all of the compost to be utilized, maybe as for the fertilizer or something, organic fertilizer, or maybe to be good for the like oyster mushroom cultivation, something. Is it possible? Because previously the composting you add some microbial to the material for the compost, just in case for the composting process. Maybe. That's just my question.
Ms. Santi, we cannot hear your voice. Maybe there is a problem with your headset, I think.
Okay, maybe I
see. Okay. Now we can hear your voice.
Let me see. Can you hear my voice now?
Yes, we can hear it clearly.
Okay, thank you. Thank you very much for the question, Pak Dedi. What I will doing for the next step for the study, maybe I will produce some consortium bacteria for inoculum, and then compare it with the commercial one, which to know the activity of the inoculum that I made. I think the eucalyptus leaf difficult to degrade, so we need some more pre-treatment before we are composting to reduce their its oil, and then after that maybe we can use it for composting. Actually, almost all organic matter can be used for compost, and the compost will be more, can be speeding up with the addition of inoculum of actinomycete, and also that is.
Yeah.
Okay. I hope my answer can reach you as well, Pak Dedi.
Yes. Yes, I think maybe that's a good idea. for maybe for your research, you are focusing on the microbe itself.
Yes.
But yes, but maybe for me, I'm so interested with the compost product from the byproduct of yours. So maybe we can continue because some to for the organic agriculture, organic cultivation, I think is still promising in Indonesia.
Yes.
Regarding how to conserve the landfill, and also maybe yes, I am agree with your suggestion about the eucalyptus. Maybe prior to the composting, is it maybe it's very important to remove. I mean, it's not remove. Maybe we should extract the oil because I think essential oil is very expensive. Yes.
Yes. That's
okay. Thank you very much, Santi. It's very interesting presentation.
Thank you.
Thank you for Ms. Santi and Mr. Dedi. Now we are moving to the last presenter. So for the last presenter is Ms. Sri Widawati with title of the test of the functional bacteria as biopriming agent to accelerate seed germination in vitro. So I will see is here and turn on her video. So can you about Ms. Sri Widawati, born and raised in Cilacap, Central Java, and Bogor, West Java. Sri Widawati earned his bachelor from Universitas Nasional Jakarta and start working as a researcher on microbiology, especially focusing on bacteria non-pathogen in Research Center for Biology LIPI since 1889. So for IT team, could you please to play a video 5 or 6?
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, my name is Sri Widawati. Today I would like to present to you about our research entitled the Functional Bacteria Test as Biopriming Agent to Accelerate in Vitro Seed Germination. We would like to thank to the Japan Society for the Promotion of Science JSPS for funding the publication fees. Functional bacteria are a group of plant growth promoting bacteria PGPR. In addition to plant, sprouts, and seedlings, bacteria functional group can also be inoculated into plant seed. The technique used for inoculating plant seed is the biopriming technique, which is effective in increasing the rate and uniformity of seed growth. This experiment aims to determine the effectiveness and activity of 5 functional bacteria as biopriming agent in accelerating the germination of 4 types of seed in vitro. Material and method. The experiment applied a completely randomized design which was organized in factorial. All treatments and control were conducted in triplicate. The first factor was liquid inoculants, Bacillus siamensis A, Chromobacterium alcaniforans B, Chromobacterium alcaniforan C, Stenotrophomonas maltopolia D, Chromobacterium phylloceum E, and control. The second factor was the seed of the Ipomai reptana poar, Leukena leucocephala, Sorghum bicolor, and Cucumis sativus. The parameters observed are the variables bacterial population in the liquid inoculants, seed germination capacity, sprout length, vigor index, and bacterial colonies on sprout. The study used A, B, C, D, and E inoculant contain 10 the power of 8 CFU per milliliter of B. siamensis, C. alcaniforan, S. maltophilia, C. alcaniforans, and C. phylloecium. After seed were soaked for 24 hours, the 4 types of seed were inoculated with A, B, C, D, and E inoculants according to the treatment and planted into a petri dish covered with wet, sterile filter paper. 10 seed per petri dish per treatment. Then incubated for 7 days at room temperature. Furthermore, the percentage of germination, vigor index, length of sprouts, and bacterial colonization on sprouts were calculated. Result and discussion. The result of bacterial population with liquid inoculant were 10 the power of 8 CFU per milliliter for all inoculants A, B, C, D, and E. Rao 1995 stated that the carrier media in inoculants should contain a bacterial population of 10 the power of 8 CFU per milliliter or per gram of carrier media. The functional bacteria test as biopriming agent to accelerate in vitro seed germination. The functional bacteria PGPR contained in inoculants A, B, C, D, and E effectively stimulate and accelerate the process of seed germination, vigor index, germination percentage, and length sprouts. 5 types of bacterial inoculation in inoculant A, B, C, D, and E on 2 seed types, E. reptana and C. sativus, resulted in germination percentage and the vigor index and length sprouts was higher than the control. One of 5 types of functional bacteria, namely C. alcaniforan or inoculant B, was able to stimulate and accelerate the seed germination of all tested seed with the highest yield on the vigor index, germination percentage, and length sprouts. Measurement results for the length of sprouts. A, C, and E inoculation on SB color and D inoculation A. leukocypala caused seed rot, didn't germinate. This can be caused by several factors such as poor seed maturity and viability, embryonic immaturity, incomplete breakdown of the physical remains of the seed, the presence of inhibitory compounds on the surface and inside the seed. These factors inhibit the imbibition process, which adversely affect the seed germination process. Bacterial colonization sprouts. The statistically highest bacterial colonization was shown by the sprout of E. reptana poa, which was inoculated by inoculant B, while the lowest colonization was shown by SB color inoculated by inoculant D. This is the product of inoculant bacteria as biopriming agent. Conclusion: the activity of functional bacteria B. siamensis inacisi B1435, C. alcaniforans inacisi B1433, C. alcaniforans inacisi B1436, S. maltophilia inacisi B1435, C. phylloecium inacisi B1437 in inoculants A, B, C, D, and E stimulated and accelerated seed germination of Ipomea reptana and C. sativus. Inoculants A, B, C, D, and E stimulated and accelerated seed germination of Lignocellulose, L. Inoculants B and D stimulated and accelerated seed germination of SB color. N. Inoculants B, C. Alcaniforans ICCB 1433 stimulated and accelerated germination of all tested seed with the highest yield on germination percentage, sprout length, and vigor index. Furthermore, 5 functional bacteria in inoculants A, B, C, D, and E, which were inoculated on 4 types of plant seed, have potential as biopriming agent. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you for Mr. Widawati for the nice presentation. Could you please open your video? Because maybe anyone here has a question for Ms. Widawati.
I'm so sorry, Miss, because suddenly something wrong with my camera, but I opened the unmute.
Okay, thank you. So here we have, yes, we can hear your voice clearly. So we have a question here from Mr. Halbert, so you can unmute your microphone.
Okay, thank you very much for your time. It's really really interesting presentation from Mrs. Sri Widawati. Hello, Miss.
Hello.
How do you do? Long time no see.
Fine. Hi, how are you?
Now, I have just a short question. How is the mode of action from this bacteria that can help the seed germination?
Repeat, please.
The mode of action, how this bacteria can really help the seed germination.
Just a minute.
That's my question. Thank you.
This bacteria maybe can help the germination because it has PGPR bacteria, because the bacteria produce EAA. You know, before I studied this biopriming, I screening the bacteria in laboratorium. Bacteria produce EAA. EAA is indicate is PGPR, you know.
Yeah. So it's mean this bacteria produce bioactive compound like
yes.
auxin or IAA that can help the seed to germinate.
Because the biopriming, biopriming is controlled hydration of seed using biological compounds. Just that the results of that biopriming is seed with Rhizobacteria is able to improve seed quality. You know.
Okay.
Okay. Is it okay?
Yeah. Thank you very much. I get it. Thank you.
Thank you, Evan. Salam sehat.
Yeah, salam.
Okay, we have a second question for Mr. Dedi. So, Mr. Dedi, could you please unmute your microphone?
Okay.
Yeah, okay.
Yeah, thank you. I'm interested with the sample of there is kangkung, lamtoro, timun, and once again I'm afraid. And is it possible to use this colony of bacteria to be utilized at some maybe hardwood seed to be germinate, or is there some consideration to use what kind of seed can be utilize this colony of bacteria for germination?
Yes, is it possible? Because because yeah, this bacteria, is it possible to the hard hardwood hardwood apa biji itu? Hardwood seed.
Oh, okay.
Because apa before before the inoculated for seed, we apa tuh soak in warm the seed soak in warm water, and then maybe 1 hour or depend the hard seed.
Yes, yes.
And then inoculated this inoculant in petri dish. See,
Yes.
so I think it's okay.
Oh, okay. Mrs. Sri, I think your research is very important because
Yes.
in maybe for some agriculture, more here in the forestry, there is some difficulty to cultivate. I'm not cultivate, but for the plantation, you make a new plantation by using seed because some problem regarding the how to germinate the very hard seed is something is problem.
Yes, okay. Yes. Just I try to make the product by inoculant bacteria for biopriming as biopriming agent. This the name is azophor, I think.
Yes.
Azophor.
Okay. Yes. Maybe yes. Shown your from your slide. I can see. Yeah.
Yes. Thank you.
Thank you very much for the good presentation.
Yes.
Thank you for Mr. Dedi and Ms. Sriwidawati. So I think there is no question again here. I just want to remind for all participants here to fill attendance form that available in the chat room. So before I close the session, please enjoy the video that we, the organizing committee, prepare for you. Thank you. IT team, please play the video. IT team, could you hear me?
Okay. Sorry, which video, Mrs. Nisa? Which one?
So actually,
The closing video or?
No, the preparing committee video.
Oh yeah, I see. Okay.
Okay.
Wait. This one?
Yes, I think yes. thank you. Now let's hear the closing speech from Head of Research Center for Biomaterials, National Research and Innovation Agency, BRIN, Dr. Akbar Hanif Dawang. So IT team, please play the video from Dr. Dawang.
Excellencies, ladies and gentlemen, we have reached the end of the first international conference of Lignocellulose, Icon-Lig, in conjunction with Excellencies, ladies and gentlemen, we have reached the end of the first international conference of Lignocellulose, Icon-Lig, in conjunction with the 10th International Symposium for Sustainable Humanosphere, ISSH 2021, that organized together by JSPS Alumni Association of Indonesia and Research Center for Biomaterials. By having this conference, we have to keep in mind this is a very special opportunity for us to go together, keep motivating with innovation and idea dealing with lignocellulose and humanosphere science. I would like to thank to all keynote speakers, invited speakers, and participants who have done outstanding sharing with us. Your sharing, your insight, and your experiences in this 2 days conference are a valuable knowledge for us. I would like to thank the JSPS Bank Office and JSPS Alumni Association of Indonesia for their great contribution and financial support. I also would like to thank the support from RISH-Kyoto University, Japan, and other participated institutions such as National Institute of Aeronautic and Space, IPB University, Universitas Islam Indonesia, Universitas Jambi, Universitas Lambung Mangkurat, Universitas Mulamarwan, Universitas Padjajaran, Universitas Trisakti, and others. Last but not least, I greatly appreciate to all those who have been involved in the organization of the event. Last, we look forward to seeing you again in the next year event. Thank you.
Okay, thank you. Now it's time for me to close our session and happily end the first international conference of lignocellulose that is held in conjunction with the 10th International Symposium of Sustainable Humanosphere. So before we close the session, can we have a photo session? Ms. Resti, can you guide the photo session?
Yeah. Okay.
So we have two pages here.
Yes.
So for one page, 3, 2, 1.
Wait a minute. Maybe all of the participants can open your camera for the
Yes.
photo session. Okay, please turn on your camera. And okay.
3, 2, 1. For the first page.
Wait a minute. Okay. Give your big smile.
So
and for the second.
For the second one, 3, 2, 1.
Okay.
Okay. Thank you. I thank you very much for an interactive session. It's such a joyful environment. We understand that some of you may require the program book for your professional interest. Therefore, we will update the program book, especially for the authors, title, and abstract section, following the final version of your paper that will be published in our Scopus Indexed proceeding. We will send the program book by your registered email. Therefore, please kindly check it, especially at the beginning of October 2021. As for the certificate, we will complete then send it to you before the end of September 2021. So before I close the session, are there any questions?
So I don't think so. I have any question here. So okay, thank you for your participation. We are so grateful to share, to enjoy this moment with you. Have a great rest of your day and see you in next event.
Thank you for all participants.
Thank you.